Are we going? Hello. Hello, please. There I am. Twitch. Hello. Nice. Good, good, good. YouTube. Okay. Pop that chat out. And then we gotta go over here. No, that's the vertical one. Where's the other one now? Here we go. Okay. There I am. Twitch. Hello. Nice. Nice, my voice. Hate it. Thank you. Cool. Okay. Okay, so I think all my chats are here. I gotta test this because this is still somewhat new to me. Let me make sure. Test Twitch. Okay, that showed up good. This is test vertical YouTube, I think. Okay. Test horizontal YouTube. Good enough. Okay. Yeah, all my chats are here. Wonderful. Wonderful. Okay. KKK. Let me go. Okay. I think actually, sorry, I know this is kind of a scuffed intro. Let me close that and pop this guy out. I'm using this because I'm vertical streaming on YouTube now. Like, I was previously just using Restream, which I still am, and Restream would just stream to Twitch and YouTube for me, but it was just my horizontal layout. And I was recommended to try out vertical streaming, and so I had to go through a whole can of worms to get that set up. But then now I have 3 chats, actually, is how it works on YouTube when you have a horizontal stream and a vertical stream. The vertical stream will show up in like the YouTube Shorts feed, live feed or something like that. So that's what I'm trying out. But it means I have 3 chats and Restream no longer grabs the 3rd chat, so I had to use like a different plugin for that. And that plugin requires me to have all the chats popped out into their own window in order to work. And it's kind of annoying, but we gotta do what we gotta do. So here we are. Yeah, what are we doing today? We're just continuing our saga from yesterday, which was terrain materials. So right now I have procedural terrain. We have terrain chunks. The chunks are chunking, but the actual material on the terrain right now is just from like a material graph, a landscape auto material. And it doesn't actually mean anything. So like this dirt and this grass is just, it's just visual, purely visual. Same with the rock in here and stuff like that. So I'm trying to actually give that meaning, which means I need an equation to generate some data, or an algorithm rather. And that's what I'm working on. And that's what we have. So I should be generating data for each vertex here. And we've got height biases. And today I'm going to be working on a slope bias. Height map slope bias specifically. So that's what those arrows were. Those are the normals. I have the normals. I ended up doing the finite difference method to get those, which I think is a pretty standard way to do it from what I've found. You know, I heard Sean Murray talk about the analytical derivative in his talk. Uh-oh, hang on. I gotta let me turn on the zoom for fucking the vertical stream. Okay, we're good. Vertical stream good. Gotta remember to do that. But I remember Sean Murray talking about the analytical derivative of noise in order to get the slope during noise calculation. But that's like super fucking complicated, it turns out. Who would have thought something called analytical derivative would be pretty complicated? And I was thinking, like, can't I just get the surrounding, like, given a point and I want to know its slope, can't I just get the surrounding points and, like, you know, like kind of just average them or something? You know, you do some math to get the normal. And turns out, yes, you can. It's not like a perfect normal, but I think it's pretty close enough for my purposes. I don't think... I feel like that's good. right? Let me look at the... I haven't actually looked underground. Let me see this here. Ooh, the underground ones are just still pointing straight up, aren't they? Okay, that's an issue, maybe. Well, I'm only using this for height map, so maybe that doesn't matter. I know I can get the normals of the points when I sample them from like a triangle perspective. But when I'm doing it on a per vertex perspective, yeah, I don't have that information. I have to have the indices to tell what order they're going in, like what direction the triangle is facing. But for the height map, it should always be up. And if I'm only using this for height map, then maybe it doesn't matter too much. This is the simple implementation. So we'll just move forward with this and see how it works out. Now, I had to put a grid spacing in here, which is hard coded just to test. So that's the first thing I'm gonna be checking out. That needs to be what is that? Scale times number of square verts, which would be 50 times 240. No, it's 50 times 6. Yeah. So scale times the mesh simplification increment is what the grid spacing is. Oh, which is annoying to pass through into this function. And I don't even know that I have that information passed into here. I'm passing in the transform, but if I'm passing in this grid spacing and this simplification stuff, I can probably just get rid of that, because the transform was put there to get around needing that. It is a little more straightforward to read, though. It's like we get the transform of the mesh that these belong to, and then we use that to put it into world space. That makes good sense. I have height map to vertex scale, which is 6. I guess I can get the transform scale and height map vertex scale. Which would be height map to vertex scale times transform get scale 3D dot just any one of them, because it's a uniform scale. I suppose that would be the easiest way to get that value in here. Put that there. Got my notes today. Okay, let's rebuild that. Make sure those normals still look okay, the little arrows. And so actually, what am I doing here? I already wrote some of the slope bias code here. We have the normal. We want to get the dot product and pass it into the curve. Yeah, so I think I just need to change the curve once this builds. Boo-doo-doo. Lo-fi Zelda fucking laps. Okay, so that build. Let's run the algo again. Here's my slope bias. So we'll see how different that looks. interesting. Okay, so let me check out, like, what some of these values are. Let me put this into a variable. The normal, so I am rendering the normal in world space, so I know that the normal looks correct-ish, but is the dot product correct? I suppose I could use a what's it called? It's like the curve float that has multiple curves on it that I can do for like an XYZ. I suppose I could just pass the normal itself in there. And then that way it could, like, I don't know, that would be weird. That would be weird. But that way it could, like, respond to each XYZ. What is the dot? 0.75. That seems correct-ish. Seems correct. Because, like, the dot product should return 1 if it is in the same direction. If the normal is in the same direction as the up vector, it should return 1. If it's directly perpendicular, it should return 0, and if it's directly opposite, it should return -1. So 0.75. Yeah, that's like almost up. Yeah, 0.8. I'm gonna look at some of these values here. Yeah, these all look pretty decent. Oh, that one's like almost straight up. Okay, this one is negative, so this one's facing down, actually. Or no, that's not the number. Okay, no, it wasn't rendering there. Yeah, these numbers look okay. It's a slope bias. Let's look at some of these numbers. 0.9, 0.9. Give me like a 0.8, yeah, 0.93, 0.65, 0.8, yeah. Okay, so maybe the slope bias just isn't strong enough. Well, let's do this. Put this over here. Okay, so let's just take this down more, so it's just stronger. Yeah, I'm not noticing more brown. Did you go negative? Times negative? Okay, let me just go up to 1, and this is essentially saying no slope bias. Okay, so it did change a little bit. Not as much as I was hoping, though. I think that's maybe because the grass bias is so strong. So if we take grass bias down to 1, this is going to be like all dirt, right? Yeah, it's like all dirt. Okay, so now dirt is too high. We'll take that down. Still a little high. Okay. Still a little high. So there's the grass, there's dirt. I mean, do we just take dirt down? Or... That's still a lot of dirt. And now the stone is starting to show through now too. And this is again, no, let me, oh no, this is with the grass slope bias. Okay, so maybe that's why. Take that up to 1. Show me what it is. No slope bias with a slope bias. Yeah, the slope bias is not affecting it very much at all. And it is being applied as a multiplier, yes, should. Grass slope bias, apply as multiplier. And do I have that code correct? Apply as multiplier and apply it. Yeah. So I'm like it's, I guess it needs to be something more like that. Or maybe more so like that? Or like that? Let me think. So, one... Wait, which side is in? I forget. As in... If I do that... Whoa. If I do something like this... That's more... Oh, I'm all backwards. Pernicock. I'm doing the bad thing and installing 5.6 from source because I'm tired of hearing about it. Why is that bad? And what are you hearing? Is there cool stuff? I think the input should be the vertical value. Yeah. So the input is the vertical values. The output is the... Or I say vertical. Input's up here. Output's out here. So when one goes in, that means it's facing directly up. That means we're not going to change the grass bias at all. And honestly, probably not even... Because 0.5 would be what? A 45-degree angle towards up? Yeah, so that's actually less. Yeah, I guess the slope isn't very strong here, is what I'm learning. And if I did that, all dirt. Mostly dirt. Yeah, I guess I was just hoping to more so just fade the noise out on... Like this part right here shouldn't really change that much. It does. My project needs a stable substrate and some of the quality of life world partition, some other small fixes. I'm not gonna wait till fucking July for the release. Okay. It sounds like a good reason. Is that difficult to do the source thing that you're saying? I always hate updating the engine. Like, at least one thing always breaks. The good news is I finally got into my GitHub. Were you locked out or something? I don't know why, but this grass slope bias does not seem to be very slopified. There we go. That's what I needed. That is doing more so what I want. Okay. That's more so what I was expecting. Okay, so we had it here. We do just 0.5 as well. Still some grass on the sides. Draconic. Really wanted to play with the new templates they have in 5.6, but I'm not sure if they were actually in GitHub yet. These are like new project templates. Are they showing some cool stuff? I kind of hate that they just... Like, it's really nice that they have the sample projects. Like, that's an awesome piece of community stuff, but it kind of sucks that that's not something that's very searchable and discoverable, like documentation wise. So for that reason, it's kind of annoying that they just rely on that instead of like Lyra is fantastic but bloated. Yeah, it would be nice if they just had some documentation on like all the systems that are in Lyra. I know I grabbed the nameplates from Lyra and used their little nameplate plugin thing, and it was only when Dr. Elliott told me about that I even knew about it. Like, that's not something you can really search, right, unless someone mentioned it on a forum. Been locked out for 6 months. Turning cog, what are you doing on your GitHub? Kind of, what, is your code that bad that they locked you out for 6 months? They're like, nah, you need to learn for a little bit before you can submit any more code. Find that out too, because they fix the samples to actually be useful. I hope you learned your lesson, Turning cog. Okay, this is looking more so like what I want. I just needed to scoot that around a little bit. Let me look at just like some flat ground. Yeah, it's still a lot of dirt. I don't want that much dirt, right? Should be mostly grass still. Yeah, we don't even need that one. Don't need that key anymore. Well, I guess, am I just taking this down? Take it down to 0.5. It's already at 0.5. Yeah, I think we needed to lerp down some more too for the stone. Okay, now it's like all stone down here. Let me do this one right here. Yeah, it's like all fucking stone. Okay, okay. Okay. You act like I've never been shadow banned from a platform. Sounds like someone who's asking to get shadow banned. Okay, I'm at an impasse here. Because... I guess this is what I needed the slope, or not the slope, the height bias strength for, because then I could just use that number. The grass, but then the slope bias would like fuck with that. Pretty easy to compile from source. It's just fiddly fuck around with the Visual Studio. Yeah, but that's cancer. I'm sorry that you have to go into Visual Studio. Just like everything else in the launcher doesn't recognize the version. Yeah, that is annoying. Is there a worse IDE than Visual Studio that's actually used right now? Like, obviously, like, Eclipse is pretty bad, but, like, no one actually fucking uses that. Xcode? Xcode is the worst that I've ever seen actually used, I think. I think I'd rather use Notepad++ over Xcode. Okay, so the problem is if I want the slope bias to affect this properly, I can't have the grass be too strong or too weak in comparison to the dirt. So either I have to increase the grass, which then means that the slope bias now just doesn't show the dirt. If I go grass up to 2. Okay, it's still good. Maybe I'm wrong here. Yeah, okay, so we're still mostly grass now too. Yeah, maybe this is okay. Maybe this is okay. Yeah, the dirt bias. Now let's take that back up to like fucking 1 here. Okay, now it's a lot of dirt. I'm not a code monkey, I just fumble around until shit does the thing. Hey, you want to know a secret? It's what we all do. We all do that. We all do that. I don't think anyone's actually understood what they were doing since like the 80s. Before Google searches became a thing. This is looking pretty okay. I think the problem still is now that it's just entirely stone down here. And I do want a little bit of dirt. No, there's like zero fucking dirt down there. There we go. There's a little bit of dirt. I thought that was the definition of a code monkey. Fumble around till shit does the thing. Yeah, we're all code monkeys on this glorious day. I remember back when I was like teaching myself how to code. Like I was an aspiring programmer, and I was just copy pasting everything, like just off Stack Overflow and shit. And I would watch these like these talks by Steve Wozniak, like, you know, the co-founder of Apple. And I would just sit there and dream, you know. And I remember him, he was like giving a talk at like UC Berkeley or something. And the way he learned how to like do the circuitry, like the circuit boards and stuff, is he would go to like the IBM warehouse or whatever, or the IBM whatever building it was, and he would dig through the dumpster and find manuals on like how to program a computer or like how the circuit boards work and stuff like that. And I was like, dude, that is fucking insane. I would never be able to do something like that. I'll just stick with my Google searches, thanks. And then he got hired by Texas Instruments when he was in high school to make the circuit boards for the calculators. And all of the full-time employees there would come to him, being a teenager, like 17 years old, and they would ask him to make their designs better, and he would make their circuit board designs. All these like adults, he would fix their circuit board designs. So what you're saying is Google is our dumpster. Google is the world's dumpster. That's their mission statement. Organize the world's trash into a universally accessible way. Something like that. Okay, I'm actually liking how this is looking. I still wish, like, stone never bordered grass, because that's weird. But maybe I can just kind of fix that up in the material. Like, I can just kind of add a rule to, like, make sure you blend to dirt before you go into stone. And it wasn't until like I had been a professional, like I'd been getting, someone decided to pay me to write code, which I thought was insane. But I had done that for like a year, and then I realized, oh yeah, no one really knows what they're doing, right? We're all just Googling shit and trying to, like, we just run it till it works, you know? And it's so funny because, like, I remember in school, like, they would just give you, like, take math class, for instance. They would just, like, you learn a new equation, then they give you a sheet of paper with, like, 50 problems on it for that one equation. And you do that until you can't get it wrong. And it's like programming is the exact opposite. You do it till you get it right once, and then you're like, beautiful, it works. Let's move on to the next thing. Which I like a lot more. That's a lot more fun. I hated the busy work. But I just think it's an interesting juxtaposition between the two worlds. But yeah, no one knows what they're doing. Thank you for coming to my TED Talk. The one problem here, the normals on the top side of this tube are pointing incorrectly. But that's okay because these are not height map vertices. I don't think that matters. I think this is looking good though. I'm pretty happy with how the hell did I get tunnels? 3D noise, my dude. Marching cubes, 3D noise plus height map. Connected them all together. I got noodles. If you're asking specifically like what are the noise functions, you do what's called like it's ridged noise. And so what you do is you generate some 3D noise, which is usually between -1 and 1, and then you do like either you square it or you do an absolute value on it, and it gives you kind of tunnel. It gives you very circular. It gives you noise that looks like. Let me find one. Let me find an actual complete one. I'm missing some terrain chunks, so yeah, maybe I don't have a good. Okay, this is maybe a good example here. Like, you see how this is just like a circle? So like the 3D noise version of this, the unaltered noise would mean like this whole area is empty, and so it would create like a little blob of empty space. But when you take the absolute value of it, you can just it just gives you like kind of like an outline of it. And so what you do is you take that and you do a min against another set of the same noise, but with a different seed, or like in a different, you know, location, and it kind of just like cross sections them, and so it'll cut up all these super circular pieces of noise. And that's why we have like these little like noise subsections and these noodle subsections that are kind of sliced up and stuff like that. And then what I did to make them more walkable was I took it and I stretched it on the X and Y axes so that you can actually walk on them and they're not too steep. So like this one actually has some height map generated on it, so this one's like completely walkable. So that's how I did that. I'm not completely happy with it because it also kind of happens to create these like super planar sections, which are kind of weird looking. Like this one's like just this isn't a very good cave in my opinion. So I want to do some more work on it. But it was a good first pass, I think, for noodles. Nudes. Okay, so I think this is okay. Let's commit this. Implement globe bias. Vertex data. Globe bias. Is spaghetti so underground you don't even know? I prefer noodles. I don't want to copy Minecraft's nomenclature exactly. Noodles. Nudes. There's kind of a lot of dirt patches though. I think I'd want it to be less dirty, but it's good for now. Good for now. Now what? Now what? I guess I need to actually do material stuff. Okay. Okie dokie, which means I need to pass this data to the material. Fuel. Fuel. So let's make a function. Generate vertex data. Take this, put it in there. Okay, so now we got a nice modular piece of code here. Good, good, good. This can probably be private. Private. Move view. Okay. And then I guess I need to now pack this all into a texture. Oh boy, is that going to be fun. Okay. So let me take a look at the vertex data. So first of all, let me do some math here. What size is this, right? So we have a t enum as byte, which I've made as a uint 8, and then we have 2 of those and a float. So we have 8 bytes. What is a float? How many bytes is a float? Four bytes of memory. Wait, so what is a uint 8 then? Hang on. Oh, it's 1 byte. Okay, not 8 bytes. I'm done. Okay, so even better, even better. Okay, so one of these chunks of one of these structs is 1, 2, plus 4, 6. So we have 6 bytes of data here. Times, let's just do a worst case scenario, which would be 41 times 41 times 41. 413,000 bytes divided by 1,000. 413, is that kilobytes now? Hang on, let me just throw that into a bit of 413,000 bytes to MB. 0.4 megabytes in the worst case scenario per chunk. Okay, so 0.43 megabytes per terrain chunk times 128 times 128. Okay, so that's 7 gigs of data for the entire world. Okay, great. That's wonderful. I love that. Again, that's the worst case scenario. That's I mean that's a scenario that would literally never happen, because I'm assuming every single point in the cube has a value, which means that the cube is essentially like a checkerboard, which does not make sense. It's probably a lot less. And the minimum amount is 6 bytes times 41 times 41, because that's just height map. So 10 kilobytes, 0.1 megabytes times 128 times 128. Okay, that's only 1 gig, 1.6 gigs. So a lot better for the entire world. It's a lot better. So somewhere in between 1.6 gigs and 7 gigs. Somewhere in between those two. Yeah, just wanted to get some ideas there. So I'm going to need a texture that I put this data into so that I can pass it into the material. Now this is vertex data. And when I have the mesh, dynamic chunk mesh, get dynamic mesh. I assume it's in get mesh pointer. Vertex colors. Yeah, so I can set the vertex color. I can set the vertex color. If I have the mesh, though. If I have it. And I do reset this mesh and get rid of it when it's out of view. But I still keep the vertex and index data, the vertex and triangle data, so that I can generate the navigation. So I wouldn't necessarily need a texture if I could just set the vertex colors on the mesh. But how does that actually get passed into the material? Can I manually pass that into the material myself? How do these eventually make their way into the material? Because you have the let me open up my landscape auto material here. Come on. Come on, let me in. Let me in. Okay, so you do have the vertex color. Yeah, so you do have this node. So it would be nice if I could just always use this node. That would be nice. How does that happen? Get vertex. Okay. Probably not data flow editor weight map paint tool. Probably not. Subdivide poly. Dynamic mesh CPP. Usages in inactive code. Yeah, none of this seems like... Okay, what about get try berry point? Pokey triangle. Wow, Pokemon. Okay. Poke result. That's so funny. Okay, where were the triangles here or whatever? Okay, yeah, the vertex info dots color. So where is this used from, if at all? Mesh. Apply, replace, change, set the color. Okay. Mesh vertex change. Yeah, it's gonna be kind of hard to figure out how these colors make their way. I wonder if I should just like search real quick instead. Unreal Engine. Well, do vertex colors get passed to material? I get that the node is how you get them. Maybe I should work backwards from the vertex color node. I should find the source for that or something. Passing custom information to material from procedural mesh. Yeah, I get how to use them. I want to know how to pass it so that I can do that for things that aren't actually a mesh. Yeah, it's gonna be so hard to search for this. Okay. Goodbye, Google. Get vertex info. What is this? Where do you expand to? Can you show me? Ryder, you're usually so good at this. Come on. Oh, it's defining Copy right on. Oh, Jesus Christ, what is this? I see nothing about colors here. It is just geometry collections. I wonder if what I should just do is... I was thinking just always have the colors set on the mesh. The vertex colors here. Even when I, like, maybe I'll reset the mesh and then just reset the mesh to 0, basically. Re-put the colors back on there, but then, like, there's not going to be any actual vertices in the mesh. So... I don't think that doesn't sound like it would work. That would probably just produce nothing. Goodness, get try berry point. Get try berry point. This is in poke triangle. Mesh geodesic functions. I guess I'm looking for a file that at some point gets out of the dynamic mesh plugin, because I know there's got to be just some general way. I wonder if I should, let me look at the procedural mesh component, because it's a little simpler. Vertex colors. How do you assign your vertex colors? Where is it? Vertex.color. Okay, find usages. I think this will probably, hoping this will lead me to the actual pipeline that uses these colors and puts them into the material. Build mesh description. F mesh description. Sounds interesting. This is just a wide open function. Doesn't belong to a class at all. The mesh description. Do you have color? Doth thou havest color? You've got the UV information. I'm sure color is here somewhere. Colors, key vertex instance attributes ref. What are we doing with these colors here? Colors equals linear color proc vertex. Yes, yes, yes. And then you're just gonna populate all the colors and do nothing with them? This has got to be... This has got to be... It's material. It's mesh. Let me see here. Where's this used from? Clicked on convert to static mesh. Not quite. Not quite. Transform polygon from 2D to 3D. Interpolate vert. This is the Kismet procedural mesh library. Wow. This is converting to a dynamic mesh. This is the same shit, right? Yeah. Do they, I mean, do they, I wonder if they just like convert it to a dynamic mesh and then it goes through the whole material thing. Let me see, let me go back. Mesh component. Do you have anything related to colors in here? Set color parameter value on materials. It's just setting a parameter. I hate the line limit. I hate it so much. Or the lack thereof. Oh my god, I hate it. I hate it. Of course, it just doesn't say... I need some material god to come in here and enlighten me. There's got to be some like rendering code somewhere that like passes the color, vertex color, to the material somehow. Primitive component. Would a primitive component, does that have a material on it? Is that that's the base one, right? No, scene component is the base one. Well, no, actor. I was wrong like 3 times in a row, right? Okay. Actor component is the base one. That's the one. I think scene component is probably what has the physical representation, right? So you probably have a material on you somewhere. It sounds right, right? Scene, that means it shows up in the scene. Hit material property path. Let me look at primitive component. Push primitive color to proxy. Oh my god, there's 141. Okay, let me do view material. Okay, yeah, okay, so I think primitive component is probably the one that has code on it. Okay, what are you implementing? Physics components, asyncon, nav relevance. Okay. View material. Just take a look at these boys. Set material. Isn't there like a, there's like a, what is it? It's like a rendering proxy, right? Like there's like a proxy class that represents the component, right? Where is that at? Unreal Engine render proxy. Primitive components render proxy. F primitive scene proxy. Is that right? That's too deep in the shit for how far I've gone. Yeah, it's too deep for me, so pray for me. Okay, primitive scene proxy. Color. Color. Selection outline, overlay color, primitive color. Primitive color? This is if it's not with shipping. Okay, so that's probably not right. Vertex color buffer. Boom. That sounds right. Okay, let's find where you're used at. Mesh merge utils, foliage edit, mesh paint, Unreal editor, probably not anywhere in there. Engine, classes, components, static mesh component. Let's look at that real quick. Apply vertex color data. Okay. That is on another struct. Static mesh component instance data. Primitive component instance data. We don't have any color information there. LOD info, override vertex colors. That's the F color vertex buffer that we're seeing. It's on a static mesh component LOD info. Okay, so I guess I've kind of figured out how a little bit the puzzle is getting pieced together here. I figured out how the static mesh does it. Mesh vertex painter, LOD info. It is just painting a static mesh data. But what do we do about all the other types of meshes? Primitive scene proxy. Let's just get. That doesn't seem very useful. Geometry framework. Mesh render buffer set. Maybe that's within the geometry framework, so maybe this is closer. Transfer vertex update to GPU, and there's color data. Yeah, so that seems relevant. This is just getting like so deep and complicated though that like, what are the chances that I can, one, find the method and way to pass it that I need to, and that it also works when there's not actually a mesh generated? Probably pretty low. Probably pretty low. I'm afraid to say. Yeah, I'm wondering if, because it wouldn't be too hard to just like, you know, what is it, 4? Oh god, what did I just do? Okay. So like, have a parameter and then like a switch, right? You can do like a little switchy switch. Or something. Isn't there like a boolean? Is it a switch? If? I suppose that works too. I have no idea how this works. God, I hate materials so much. Now, what is this? Is this the boolean? How do I use a bool? What can I use you for? Where was that other... bang bang. Came in shooting, didn't you? Okay, give me this. Go here. There was one in here, right? What is this? Switch param. How do I make that? Yeah, so that's what I would want. And this would be something like use vertex colors, and that would be checked. And that's a param, so I would set that from outside. Okay, yeah, that makes sense. Default value is false, so just use the texture. I think default value should probably be. But yeah, so it's not that hard to do that, right? Oh god. Yeah, so it's not that hard to do that. It's probably very hard to pass vertex colors to a mesh that's not actually a mesh, to get it to the material that doesn't actually have vertices, when it would work the same way. Denim, welcome. We're talking vertex colors. We got our data. We got our vertex data here. Here's our vertex data. Height bias, slope bias. Now we actually need to feed this vertex data to the material so we can actually, you know, render that. That's what we're working on. That's what we're working on. We just got the slope bias working earlier. but the material that's on there now just doesn't do anything. It's just a landscape auto material. So I want to make this not just be a visual representation, but actually mean something. This will be for things like terrain deformation, right? Like you want stone to react differently than dirt when you hit it with a pickaxe. So I'll need to get this data here. Saw the procedural cave-like system before, very sick. Thank you. Yeah, I was very, very happy to get that done. That was like a breakthrough for me, getting that done. Because it's like we have the normal kind of like 2D height map, which is just kind of like a blanket laid on top of the world. So there's no like overhangs, and there's nothing like that can be done with the height map. Then combine that with some 3D noise to make some cool little terrain features. So yeah. And noodles. We have noodles that are walkable, which is fun. What do I store in vertex color? It's going to be it's going to be a total of 6 bytes of data. 2 uint8s that represent materials. Those are going to be like material IDs. You know, like that'll be like dirt, stone, grass. And then there'll be a float alpha for the blend between the two. That's what I'm putting in there. And so I'll need some sort of map of ID to what the actual material is, or like the texture that I should render. And yeah, like I said, that's for things like terrain deformation. So when you hit dirt with a shovel, it reacts properly, and it reacts differently than hitting stone with a shovel. And same with the pickaxe as well. It's also going to be for PCG. So when I spawn PCG on things, I want to know what is the underlying point, right? Because for PCG, you sample points on a landscape. I don't have a landscape, right? I'm not even going to have a mesh with collision on it, right? Because there's all these meshes out here that aren't actually meshes. It's just data. It's just vertex and triangle data. So no actual collision. But this system now doesn't even rely on collision anymore, which is cool. And like you can see that with my player, like I'm actually doing my own little collision trace here with my player. It doesn't actually use collision at all, actually. It just does math, and it looks at the vertex and triangle arrays, and then it can figure out, you know, what the data is at those locations. And this is just doing like a cast basically from my crotchular region down to down to the feetsies. And so when I run around, you'll see it changes to what is underneath my player. Dirt over here, I suppose. And so that'll be for things like move speed based on what material you're on, and like footstep sounds, right? Like that's something traditionally that you would use physical materials for, which I looked into briefly, and like, oh my god, there are so many caveats with the physical materials. Like it was like, so like if you wanted multiple footstep sounds for like one, like let's say you have a landscape auto material like I have. If I wanted multiple sounds for different textures within the same material, like that's just a massive pain in the ass, apparently, with physical materials. So yeah, we're gonna do move speed, footstep sounds, and stuff like that with this data as well. I want like a bug-like race, like a Zerg, like a StarCraft 2 Zerg type race that spreads creep. And I want the bug entities to react differently to the creep than the player and colonist entities do as well. So maybe bugs move a little bit faster, maybe everyone else moves a little bit slower, that kind of stuff. So kind of 3 main things that I'm going to use it for: PCG points, figuring out where to spawn stuff, gameplay related effects like move speed and sound, and then rendering, like what is actually rendered here. Yeah. Oh, and terrain deformation. So like 4 things. Terrain deformation as well. That kind of falls under gameplay though a little bit. So that's what we're cooking up. And so now I'm kind of working on the material side of things, and I was trying to figure out how to get these colors passed to the material. And these are all dynamic mesh components, so I can just set vertex colors with this data. Maybe I should just always pass it in with a texture. That way it's the same all the time. Like, I don't, why would I use for vertex colors if I don't need it, right? Yeah, so maybe we don't even do that. And that way it's just consistent. I think that's actually way simpler. I guess I need the... because I'm gonna need to bake in the location, right? That's gonna need to be baked in somehow. And I guess that would be... I mean, it's a texture, so like, would I need a texture volume for 3D? Yeah, packing this data is going to be kind of a nightmare, isn't it? Because you can do the XY, but I suppose I also need the Z. Yeah, this is gonna be what I would call a pain. And then I also kind of have to make some sort of distinction between pixel space and vertex space here. Isn't there like a vertex? Isn't there like a vertex interpolator? Yeah, so that can change between pixel space and vertex space. Do I need the XYZ? Do I need the absolute world position? I mean, I guess I have that. I guess I have that, but then how would I make sure that the texture is like packed properly? How would I get the right value from the texture, I guess, is what I'm asking. Yeah, I guess I need to understand how to actually work with the vertex data now. And that'll kind of inform how I should pack it. Shall we watch a video? Let's watch a Prismatica video as a refresher. Good old Charlie. Prismatica vertex color. Intro to vertex color. Cool. Do that.
We're going to be talking about vertex color in terms of 3D modeling and how we can apply vertex color in Unreal Engine. So, what is vertex color? Well, it's probably easier for me to just show you, and we'll kind of explain it as we go along. So, before we jump into
video. Holy
the
shit.
engine,
Okay.
the first thing we should do is actually talk about what is vertex color. Where does it come from? Where does it go? Where does it come from, Cotton Eye Joe? So if we just grab this cube, and we're actually just going to subdivide it a few times. That's probably good enough. And then what we will do is, up top left, we're just going to go vertex paint mode. And you can see here, if I just select a color, you know, purple or something, we can just paint on this cube. Now, this color data here, you could kind of think of it as a texture that is built in to the object itself. So what we'll do, we will go to paint. We're just going to set this to be black to begin with. Set vertex colors. We can go, you know, red. Let's put red up here for an effect of some sort. And then let's just add some I don't know, green for good measure. And we'll do that on this side. And then just for the sake of it, let's do like a little line of blue along the middle, like around the middle, like this. Just for fun. You know, sometimes it's good to have fun. Cool. Now, one thing that you will notice about when we're painting stuff here, if I paint with a really intense brush stroke, so if I just paint right here, you'll see that it's kind of got this pixely pattern to it. Now, the reason that we're getting this kind of pixely, you know, weird pattern is because this is limited by the verts of the mesh. So you can see here, if I paint this corner, it's going to say this corner's red, this corner's red, this corner's red, this corner is white, and that's why we get this sort of square pattern.
Looks like a rupee.
Now, this can be masked pretty effectively in Engine, and that's one of the things that we'll actually take a look at. So I'm going to go ahead and export this cube to Unreal, and we're going to investigate a little bit further. But before we do that, we're going to talk about the sponsor of today's video, and, you know, we're all still doing of Skillshare. So thank you once again to Skillshare for sponsoring today's video. So we've got our cube, we've put it into our scene, and it's just white. It's just a default material. What we need to do is go into our material editor, and we're going to recall the vertex color node.
Okay.
Where are we? And if we plug in the RGB channel, then this will show up like it did in Blender. Now, the majority of the time, you will be using this for utility
purposes. How is that
purposes.
packed, though?
So you'll probably be isolating the individual channels to use for some effects and some masks and stuff. So if we look at just the red channel, this is what it looks like. If we look at just the green channel, this is what it looks like. If we look at just the blue channel, then this is what it looks like. So far, this has been absolutely useless. However, you can
I won't be importing a mesh, though. Like, mine are all generated, so...
with vertex color.
I'll be doing it quite a bit
vertex
differently.
Color, as we saw in Blender, is very low resolution, or at least it's limited to the resolution of the vertices of the mesh. But there are ways that we can add detail to break up this gradient. So one of those ways is using a height lerp, which I have a video about up here. It's on my channel somewhere. Just look up height lerp. And the way we set one of them up is we get our transition value, which is going to be the vertex color in this case. We multiply it by 2. We get a texture that we're using as the kind of height texture. I'm going to use a brick wall, and its height data is in the B channel. We're going to get that, subtract 1, we add these together, and then we apply some contrast. And just to make this look a little bit more appealing, a little bit more relevant, I'm just going to set this material up so that it lerps between a brick pattern and a kind of destroyed rock stone pattern. So we've got our brick texture here. This would usually be a normal map and a height map, but I do some funky stuff to, you know, not do that. We're going to use a lerp using this transition value between this and our other texture, which is going to be our wall 03 texture. That's going to go into here. This is then going to go into the normal. The color we're going to get rid of. We're going to go between a nice kind of bluestone color and a kind of more broken sandstony color. And we're also just going to get our text coords and make this tile a little more. All right, and now if we up the contrast a little again, then you can see this is starting to look like, you know, an actual effect.
Okay, yeah, I guess I'm needing to understand how the vertex data is like packed. Like the per vertex colors. I mean, maybe I should keep looking in the source code. Because, like, this is great for, like, how to use it, and that is, I will probably need to watch the rest of that to remind myself. Vertex buffer. Vertex color buffer. Yeah, I guess it's, vertices and stuff. I guess this is just where my understanding of materials breaks down. I guess this only really... Wait a second. So I guess this only really matters when I actually... Am I dumb? Yeah, I'm dumb for thinking about this way. Yeah, I should... Like, this, I'm only doing this for when the fucking mesh is rendered. Why am I sitting here considering... Why am I sitting here considering when the mesh isn't rendered and I don't have vertex colors? I don't need to do that. I guess I was like, one of the ways I was thinking about approaching this whole vertex data was generating the vertex data in a material was one of the things I was considering, and I was thinking like, oh, I would need to do something like this for that. And I guess maybe I was just like biased by that previous implementation thought. But yeah, we don't need that at all, actually. Yeah, we're just always going to pass in the vertex colors. Okay. Yeah, dumb. So, mesh pointer, color, the colors buffer. I just set that. It's a float? Oh no, it's a vector. Oh, it's a float vector, okay. Set vertex color, vertex ID. I just want to like wholesale set all the vertices. Kind of annoying they don't have a function for that. How do I get the vertex ID? Is this it? I can get vertices buffer, but that just gives me a vector, not the vertex ID, which is, I guess, what I need. This takes in a vertex ID. How do I get fucking vertex ID? Where is this vertex ID coming from? Tell me. Tell me where. Is that just the index, I wonder? Yes. Yes, it is. Wait a second. Okay, so yeah, I guess I can just straight set them with the vertex IDs. I think. Let's assume that ID is indexed. Dynamic chunk mesh. Vertices buffer. Get mesh pointer. Set vertex color at I. F. Terrain vertex data, terrain vertex data, bing bang boom. Okay, put the vertex data. Yeah, and here's where I need to decide what actual color I'm putting in here and what that color represents. So I could, the first easy pass of this would just be to use the alpha to get whether A or B is higher, and then just pass in my debug colors, and then I can just make a map of debug color to like what texture I want to show, right? But I know I'm going to need something more than that in the future. So I'm thinking I just like maybe pack in this data a little differently. I could put, you know, this into one channel, this into another one, and this into a third one. Which could be something. It's F color, right? Oh, it's an F vector 3F. Okay. It's only a vector 3? Wait, does this have 4 components? Or a 3? It's a vector 3. Okay. So I only have 3 components to work with here. Okay. I mean, that's all I need, but... Okay. Sure. Yeah, so we can just do something like that. That's pretty simple. It should be vector 4. Yeah, this seems like a limitation of the dynamic mesh library. But that's fine. I mean, I could figure out some other way to like make the numbers, you know, fit into a channel. But this is fine for now. I don't need all of them. Okay. So vertex colors are set. Now what? I should probably only do this if... Let's only do this. Generate vertex data. We want to generate the vertex data anytime we're finished with the vertices. Just right here. But we only need to actually set the vertices colors if B mesh rendered. Where do I set mesh rendered? I set it right there. Okay, so that should be set properly. No, we need to do this. Okay, but we get the vertices buffer mesh done. That's mesh done generating, not rendering. Just done here. Mesh rendered. Okay. Okay, I need to do that in 2 steps then. So we're gonna generate the vertex data in 1 step. And then in render mesh is where we should, well, yeah, that makes sense, because that's where I'm like doing all the material stuff anyway. So where's that material? Where's my material function? There it is. There it is. And that way we don't even need to check if the mesh is rendered, because we only get here. We only apply material when the mesh is rendered. Make a little function for this. Rain chunk. Set vertex colors. Okay. You are private. Good. Good. Vertex data, dynamic chunk mesh, setting material, setting a texture parameter for the height map. Okay, I forgot I was doing this. Yeah, so I guess I have the height map in here. Yeah, there it is. I'm not doing anything with that. Do I want the height map still? No, because everything should come from the vertex data. Right, like if I'm doing extra stuff, max world height and stuff like that, that should all be a part of the vertex data. Yeah, that should all be baked in and stuff. So max world height. Yeah, let's just comment this out for now. Set vertex colors, set material. My dog is napping on my sweater. Look at him. Okay, so yeah, we no longer have a max world height now. This is all going to be, oh, this is all going to change. Oh boy. Okay, what do I have here? Okay, so we have, this is grass, and I use a little bit of noise to lerp-de-derp. To just give it a little bit of difference there. Grass, texture coordinate, multiply. Okay, I'm gonna move this up here. This is all in one chunk. This is all one thing. It's one idea. Move that up here. This was, I think, the old way of how I was doing it. Dirt. Let's just put you right there. Dirt, sand or whatever, yeah. Okay, so I guess I need like, I need to correlate those IDs. Where is it? I need to correlate these IDs to, so this would be like 0, 1, 2, 3, I believe, to textures. You have working with UVs with your generated mesh? Yes. So what would be, there's like a, there's got to be like a thing, right? There's got to be like a, there's like an asset or something. Let me look at, what are my parameters here? Curve atlas, something atlas, right? There's got to be an atlas something or other that I can use. Texture atlas, maybe? Texture parameter 2D. What about just like a texture array? Is there a texture array? Texture sample parameter 2D. There's a 2D array. Is that what I'm looking for? Why does this not seem like an array? Why is this not an array? I'm expecting this to work differently from texture assets. Or the texture has to define the array, I suppose? How do I use a fucking texture array? Okay. Using arrays in materials. Material parameter collection. Let me take a step back and just do a quick search just to make sure I'm on the right track here. Unreal Engine material. I need to correlate an ID. Like a texture, like map, essentially. How are texture map made? Okay. Texture ID map maybe is a better way to search for that. God, everything means something different in materials, and it makes it hard for someone who doesn't know the nomenclature to actually fucking... Unreal Engine material, choose texture by ID. Applying a texture to a material on a mesh with IDs. No responses. Texture. Okay, let me look here. Texture 2D array, render target, render texture 2D array. Why is it 2? What does the 2D mean here? Okay, this is fucking meaningless to me. How do I put different textures into an array? Source texture to add textures. Wait, is that in here? Or is it over here? Source file. Okay. Source textures. I see. Why did that not show up? It did. I just didn't see it because I'm dumb. Okay. Ah, okay, wonderful. Okay, that's making more sense as to how to use that now. Okay. And so how do I get from that? Do I have to, is that the UVs? Is that what that's for? So then I would go like, I put it in R, and I would need another one for G or something, maybe? Something like that, perhaps? And then this would then be the texture, okay. So let's just throw like a few Which sucks because, like, yeah, I need all this to, like, be a texture. But I guess I go in here and, like, grab whatever texture this is. So this guy. Okay, you will be, well, we're gonna put none at 1. Okay, 1 second. I'm gonna be right back. 5 minutes, guys. 5 minutes. Here. Okay. We're back. Apologies. Okay.
in order to do this, I'm just going to move all of...
I'm trying to find some answers here.
This stuff out of the way. I'm just going to move all of it up here. And let's kind of start fresh because we don't want texture here. And in this sample, I'm going to sample something called a texture array. Now, first of all, I need to explain what that is. A texture array is kind of like a stack of textures. Instead of just having one texture map, I've made an asset where I have multiple texture maps all together in a stack. So let's go ahead and create one of those. I'm going to open up my content drawer here, switch over to textures, and I'm going to right click here and pick materials and textures. Then I'm going to come down here and I'm going to pick texture 2D. Then I'm going to open this up and you can see that immediately it's completely blank. Well, why is that? It's because I haven't added anything to my stack yet. Right here where it says source textures 0 array elements, that means my stack is empty. And we know that we're using 4 different textures. We're using denim, felt, leather, and linen. And so I'm just going to go ahead and click this add button right here and add.
You know what? Maybe I should. I'm thinking actually now, maybe because like this isn't a texture, right? I mean, there's a texture underlying there somewhere, but I'm wondering if I should just like, is there a way I can just like get int float to uint? Yeah, that's I think that's probably what I want. God, I hate how I can't just like click on this and see the goddamn source code. Hate that. Anyways, I can do this int and then just like switch. God, I have to do the oh my god, my programmer brain is freaking out right now. Ugh. I just want to. I want a switch case statement. That's what I fucking want here. Let me see here. Unreal Engine material switch case. Are you fucking serious? I mean, sure, I'll write. I mean, honestly, HLSL is easier than. Oh, what do I actually write the function here though? Like, what do I put here actually? Okay, and I could just name the outputs, right? Or no? Yeah, what I keep thinking in terms of like writing code here. But I guess I can't really, even if I did have like the switch case like what I want, how would I like, I couldn't like branch it. Dynamic branch? Yeah, it's not. There is the if else, right? Like, there is this node, but that's... You can just do a bunch of those, but I guess that's kind of what lerp is doing too, anyways. So maybe it's all just lerps, right? Maybe I just lerp and the alpha is... What would the alpha be here? Like this is like an ID or some shit. Right, basically I need like, here's another track. Here's another one. There's another one. So I have like an integer and I need to know like what this integer represents. So like 1 would be grass, right? So alpha would be what? It's like the amount of this texture, right, that I'm expecting. This versus the other one. So really that's like this alpha, right? And so the A and B, it would have to be, I have to do some math, right? I have to like divide this by like something or other. I need to like, do I divide this by the index that I have here? If this is like 2, this should be like 0, right? So it should be basically A if it's correct, right? So if I have 0, well no. It needs to be exactly 1, actually, if it's like the right number. And if we do this in like an increasing fashion, I think that would be fine. I think we need to do a 1 minus to this. We divide by 1. And if we get 1, then we know it's what we want. So we want to do like a 1 minus to get to do 0. If it's below 0, that means that this is an index by 1. That would be like for this one. Actually, so then we would probably take that. Material attributes is not compatible with float. I am using blend material attributes instead. So would it be the 1? So no, we would get. Yeah, I think this may actually be correct because an A is like nothing, right? That's like no texture. Let's put like a. Let's do like a where's like the default give me like the default grid texture or whatever. Default alpha texture? Sure. Oh, I have to like make material attributes from that. That's annoying. Just fucking put that way over there. Okay. HLSL makes me feel stupid. I need to understand how the code flows. Dude, I understand HLSL more so than material graphs. Because it's more so like code, right? Okay, and so then we keep doing this, right? We keep doing this, but we divide by a different number. And then it should be fine. Pass this into A and this into here. Oh, shit. That into there instead, and we divide instead by dirt is 2. Yes, so divide by 2, put that into alpha. Wait, why is that feature level 6? We're converting between float 3 and float 4. What is it? What is this? Is it float 4 or something? Wait, how do I get the... Isn't it just a mask? What is this? Okay, hang on. Is this a... What is this? Oh, I hate how I can't see types either. Get the texture array out of here. I'm not using that anymore. Do I need to do that? Or do that. That's probably where I went wrong, right? Oh god, I clicked save. Okay. There we go. Okay, so divide by 2, that's the alpha. If we divide by, if it's higher than that, it's going to be 0, or it's going to be lower than 1, which means we keep the A. I feel like this is a really shitty way to do this, and there's probably a better way. Get that out of here. I feel like this is actually really maybe I should just write the HLSL for it. Okay, hang on. Let's think about that for a second. How do I actually use like functions and stuff? How do I actually use inputs and outputs here? Input name is none. Okay. I'm gonna go out on a limb and say there's no documentation for this. There is actually. Wow. Shocked. Input arguments are function local. And custom expressions always have a return value because they're wrapped inside of a function. Okay, I guess I just have to kind of read their code here. Okay, text. Okay, so that just gets passed in. How do you? Oh, and then you just have the return statement. Okay. Okay, so I just need it to return a scalar, so a float 1, and the inputs. Go back. The input. This is going to be the material ID. Well, I guess I need 2 inputs. I'll do in material ID and desired material ID. What is this? Okay, so this is the in material desired make go. I want ID 1, right? So this is like get blend value, get material ID blend value. Okay, that's essentially what this is. The output, I did make a float 1. Okay, cool. Where oh, that's the code. Duh. Okay, so I need to basically, we're gonna return in material ID equal to, wait, are there I don't even know if there's ternaries. If in material ID equals 1, if in material ID equals desired material ID, return 1. Hopefully that compiles. Okay, now we don't have to do this wonky division that I don't necessarily know if it worked or not. Okay, but we have to do this. I have to do this like a bunch, don't I? Shit. Wait, how do I like copy this? I wonder if I should make a material function with it. We should probably do that, right? That's how you can reuse this. God, dude, everything feels so janky in materials. It all feels like a hack. Okay, material function. What did I call it? Oh my god, dude. Come on now. Get material ID blend value. Okay. Copy you. Okay, so how do I How do I do... how do I make a material function? Is it it's probably just parameters, right? Convert to parameter. This is going to be in material ID. Another scalar for convert that to desired material ID. Okay. Here we go. Come on now. Come on. Unreal Engine. Hi. Yes, I would like to use you, please. I would like to do things. Thank you. Brain already looking a bit different. We can get a lot of this stuff out of here. Let's just close this. The fucking MyGrass. Sure, we'll rename you to MS, MF. And then do I define like what the output is here, or is it just kind of inferred? Output name, blend amount, description. I mean, it should be, it's a scalar, so. Dude, I hate that you just like don't. I cannot explain enough. I guess it just compiles, and then that's how it knows. Okay, so material function call. We want, yeah, that one actually. Wait, where are the inputs at? No. Material blend mode. Thumbnail info. Is there an input? Function input. There we go. Okay. That's probably what we want. Input, scalar, name it in material ID. Okay, get rid of those. Give me another one of those. Desired material ID. Cool. Cool. Okay, now we're cooking. It's a scalar. I don't know why the preview value. Oh, that's for the node preview. Use preview as default. Sure. I mean, it doesn't matter. It doesn't matter. Okay. Okay, now this is going to be nice and nice here. They're ordered in the opposite way that I wanted them to, but sure, that's fine. That's fine. Can I do a named reroute? I can. Okay, so material ID. And so then can I do a material? Oh my god, come on, please. Cool, nice. Okay, so then we're just gonna store that. Material ID. Wow, who would have thought that you can actually make variables in a fucking material? Who would have thought? Backwards. Go. Okay, that'll go in there. Beautiful. And then I need to call it again. Okay. Nice. Okay, now we're cooking. Now we're fucking cooking. Give me that. You are now... Oh, what are you now? We can just close that. Now you are 2. You are 2. Oh my god, this looks crazy. Fucking looks crazy, dude. Did I create God? I think I created God. What is the... Oh. Beautiful. Do I have my IDs wrong, maybe? Does this start with, Maybe I should... Yeah, let's like, let's do this, just to make it more explicit. I thought that this is what they were already. Right, don't you, can't you do what I'm doing here? Yeah, you set it equal to 0 and stuff. Okay. We may need to rebuild there to get that to actually take effect. Okay, dirt. Oh no, this is to the same thing that should be here, I think. This is dirt. Wait, this is sand to... Oh, I forgot what I did. I don't have sand anymore. So this probably just all needs to change, but we're going to keep it as similar as possible for as long as possible, just to make it easy. Absolute world position. We're not going to do anything with you anymore. This is grass to dirt, so I think that's what that actually should have been. And these need to be swapped. It's all dirt. It's all dirt. I don't actually have the code where I'm passing in the stuff, so let's go ahead and rebuild it. Let's rebuild this because we weren't actually ever setting the colors, so this way we can actually work with it. Okay, come on now. It's a neat photo. Okay, we're back. And we're back. Get some terrain generated. Okay, where is this coming from? Ah, okay, yeah, that's fine. That's fine. Oh, is this gonna happen for every goddamn arrow drawn? Because it's happening on... Okay, alright, okay. Okay, we're gonna have to build that. We don't necessarily need that arrow anymore. It is nice to have it though, so I'm just gonna keep it commented out. Bro, I rebuilt the engine faster than this. Live coding. What is your job here? What would you say you do here? Well, we're waiting. Oh my god, dude. Okay, I'm just gonna rebuild the engine at this point. Like, come on. Is live coding this bad for anyone else? Like, I feel like it got way worse. What was it? Was it 5.5 or 5.4? I forget which. I updated the engine and live coding just got substantially worse. Live coding a bit longer the first time, then it's fast for me. So what it used to do is that it would never recompile something it already compiled in live coding. Like I made a change to what file was this? I made a change to the vertex data generator file, and so it was it did a couple recompiles for that. If I went in and I changed the terrain chunk file after that it had finished compiling, it would still recompile this one. And so the more I ran live coding, the longer it would take each time because it would have to recompile more. it would recompile more files, and it didn't used to do that. Didn't used to do that. Okay. It's all dirt. Okay. So we should be setting the vertex color. I hope. Maybe I should have checked if we're just even setting that properly. Okay, so if this is the one that I want, it returns 1. I'll put the vertex color. That's a good call. Good call. But it's all just ones and zeros. Like it's actually this is nothing. Yeah, it's not going to show me anything actually. Because it's 0, 1, 2, and 3. So that's not going to show up very well. Shouldn't that be black though? Okay, so we're gonna we'll start simple here. Just show me this one. Oh, what is this? This is material attributes, which means I need like a break, or can't I do? Isn't there like a way to like use material attributes? There we go. Yeah, that's what I want. Okay. There we go. Cool. And then let's just put this one out. Apply. We'll just do it one lerp at a time. Fun. Fun. Okay, so this is 0 to 1. Why do I feel like this is like always returning 0 or something? Let me just change this to just, is this even... Sweet. Sweet. Okay. Just out of curiosity, let's do this. Apply. Okay. Okay, that's a thing. Yeah, I wonder if I should. So this is material attributes, is it? Maybe can I just like, can I do like break material attributes? Maybe I should just be blending base color with base color here with a lerp. Try this. Alpha. Give me that. Should be A. Base color. Let's see what this looks like. And then I would need to, yeah, like make material attributes. Yeah. It's still a very weird. Well, are you trying to set vertex color channel value out of 0, 1 range? No. Okay, so vertex color. What is the color of this vertex? Okay, let's just like put a 0.5 in there. What does that look like? Okay, that looks a lot better. Okay. It is like, yeah, halfway between the two, I suppose. Oh, the RGB values are 0 to 1 is what you're saying? Okay. So then I would need to do... I mean, I was returning 1 there, so... desired material ID equals 1, so then I would need to do, like, divided by 255. Right? Or no, this desired divided by 255. But it still looks fucking weird. Okay, that's the wrong direction. So we got 0, so... In material, desired material ID divided by... So, like... It'd be like 1 divided by 255. That's annoying. Is there a better way to, like... The material ID... If I'm passing in... like the number 1. Maybe this needs to be... Let me see where this is used from. F linear color. So that should be between... That should be in the 0 to 255 range. Although this is doing 1s and 0s. It's casting a linear color to a F vector 3F. Does that do like an automatic conversion? No, it just directly is linear color between 0 and 1. Oh, yes, it is. Okay. From power, I think it is. I don't know what that's doing. Hang on. Unreal Engine is linear color between 0 and 1. Let me just look up linear color. Can I just get a simple fucking answer? Is linear color between 0 and 1? A simple answer would suffice. Okay, let's try this then. Should I do that? Vertex data alpha should already be between 0 and 1. Okay. So does that change anything? Well, I guess I need to rebuild the thing, don't I? Okay, so it's all look at that landscape. That's a sick fucking landscape. Floating point representation of color. I'm trying to see like what would get passed in here. Yeah, see, this is doing ones and zeros. That makes me think that that is the case. Okay, yeah, so this should be like... should be between 0 and 1. So yeah, dividing by 255 should take what is like a 1, 2, or 3 and put it in the right space. Although it's like floating point numbers. So is that going to be like the fucking same as doing this math here? If in material ID it did something. Yeah, I know F color is like that, and then I guess to divide by 255 sounds correct. Yeah, that's what I'm thinking. That's what I'm thinking. And if I just return, let me just return 1 here. Why does returning 1 still give me the A? Isn't like 1 means B, 0 means A, right? Or do I have that backwards? Do I have that backwards? I do indeed fucking have that backwards, don't I? Yep, okay. Bingo. Okay, I had it backward. There's the issue. There's the issue. Okay. Where is emissive color? There it is. Wait a fucking... oh yeah, I need to go back and change this. Don't do that. There we go. Okay, that's what I'm expecting. Look at that. Now we have grass. Now we have grass. That was the issue. I just had lerp backwards. Like I was thinking 0 to 1, but it's actually 1 to 0. Okay, cool, cool. Just put them backwards for me. So we would want the output of this to go into right. Yeah, what the hell was I putting in there before? Oh, that is that. Okay, right. Wait, what? B is 1? I'm now confused. Wait, is it? So then why does this So then this is wrong then. If in material is equal to desired material ID divided by 255. Let me do this. Let's get to the bottom of this. Maybe these maybe we're not even putting the data in there. I thought B was 1 too. That would make sense. Okay. Vertex data. What do we have? We have data. Stone and grass. What is R here? Okay, so stone should be 3. So let's do the math. 3 divided by 255. No, that's right. Already fat fingered it wrong. 0.117 blah 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 blah. 0.117 blah 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 blah. There's precision errors. Yeah, that's kind of what I was thinking too. Like, I don't know that the math works the same way. So maybe just divide by 100. That should be enough, right? 100 should be enough for all my cases. Let's do that. And that's easy math, right? Divide by 100. Something nice and easy mathy. Better to divide by 10, but then I could only have 10 materials. Okay, so get in here, divide by 10, save that. Does that apply automatically, or do I probably have to go back into the material and click apply after I change the function? Okay, it's still working, which it shouldn't because reasons. Okay, so if I put 1 in here, it should be all grid. Yeah, and 0 is all grass. Okay, all grass, no breaks. So yeah, it's wrong still. It should not be a grid. It should not be grid. What is this fucking number? What is this fucking number? Is there a way? I wish. Oh my god! I wish I had print statements. My kingdom for a print. Is there a print statement? Print. No. Debug. I have no idea how to use any of that. Okay. It's 69, right? Yeah. The ID for material 69, it has to be some sort of Easter egg, right? The material for ID 69 has to be some sort of Easter egg. Print statements and shaders would be glorious. I know, right? Like, I just want this to be code. Can this just be code, please? Yeah, so why wouldn't this be getting? So let's just... Let me look up. Let me show me the. Show me this. Okay, so it says any scalar value. Maybe I just need a little bit of tolerance in there. Was there like a function for equals with... It was a floor. Frac. There's printf. I wonder what that would do in the custom node. Round. What else do I have here? Trunc. Truncate it to an int. Yeah, but that wouldn't really do anything for me, would it? Yeah, I mean, why wouldn't it divide by... Oh, I divided by 10 here instead of 100. I'm a fucking idiot. Okay, that's why it didn't work. Okay, still doesn't work. Never mind. Wait, hit apply? No, okay, still doesn't work. That wasn't it. Divided by 100. So this is still producing 0. Okay, you're just saying to multiply instead of divide on the other side. Okay, we'll try multiplying by the other side. And then I guess we can use the trunc function now because this should be an integer. And then I guess we'll trunc the other one too, just to make it consistent. Apply. Still nada. What are these fucking numbers? What is this number here? What is this number? I think this is just fucking 0 for some reason. Let me go back in here. Let's look at these real quick. .2. Why is this 0.29? Oh no. You really gotta do me like that. So yeah, no wonder. These are off by a little bit. Okay, I guess we can try and work with that imprecision, right? We can work with that. I think we can work with that if we keep doing times 100 in material ID times 100. Because that should be 0 to 1, should be in the decimal times 100. We put it as an integer. If we truncate it, we should round it instead of truncate, right? That's what we should do. Does that help? Looks great. Let's ship it. I guess round, what is that round to? Let me look at round real quick here. I can't spell. Where's round? There it is. Rounds a specified value to the nearest integer. Right, like that should, I feel like that should be working. Round in material ID. which is the vertex data material ID. Let's just which would be 0 to 1. We multiply that by 100 and round it. So that should be an integer, right? Let's also do this. Int desired. This way we make sure that they're ints. If in equals desired. Okay, still nothing. Desired material ID 1. If I did desired material ID 0. Two. Three. Okay, I feel like the vertex data is not getting populated properly. Set vertex color if has. Okay, oh, you know what? You know what? This is, bro, we probably had this right a long fucking time ago. Yeah, we probably had this right a long fucking time ago. And it was a, yeah. The data wasn't getting passed. Okay. Yeah, because that was very suspicious. And like when we plugged in the vertex data, it was just all white. And I was like, that should probably be all black instead. Yeah, we probably had that right a long fucking time ago, didn't we? Okay, run it back. Okay, so now maybe that data is actually getting populated. 3, change that to 1. Still nothing? Is there a way to see the vertex data? The colors? No. Okay, let's try plugging in the vertex data again, because it should be black, right? Yeah, this way over there. Okay. Give me. Just give me all of it. It's white. Well, that's just the preview. Yeah, it's all white still. I feel like it should be black. Enable vertex colors, initial color. I'm wondering if the vertex IDs aren't even right. It is just setting it at the index though. And I never hit this. And there's not like a get vertex or whatever. Get extended vertex information. That's interesting. But again, it takes in the ID, which I'm not 100% certain I mean, that's got to be the index, right? If that's the index, then what are we doing here? Let me make sure my terrain vertex data... vertex data. I do iterate over the vertices, right? Yeah. So we're doing the same index. The same indexing as the vertex buffer. Just down here. Mesh generator. Yeah, we're just directly passing it in. The vertices just go straight in. So theoretically, we are setting the colors correctly. So let me do this then. Where were we? Right here. Let me put a log there so I can breakpoint on it. Okay, let's rebuild here. Okay, let me look at the vertex colors for this guy here. Caps recaps. Hello over on YouTube. Welcome in. We're trying to figure out vertex colors for our dynamic mesh component procedural terrain. Where's the mesh pointer? Or no, we want dynamic chunk mesh. Where are you at? There we go, dynamic chunk mesh. We need to get the dynamic mesh. I wonder... Wait. It should already... Yeah, everything should already be set there, so... We can make functions in HLSL. I was using macros as functions. Wait, what do you mean? You mean like the custom node in materials? Or do you mean like in compute shaders? I'm confused. Let me find the... I guess it's probably in here. Where's the mesh pointer at? Here's a mesh object. I suppose that's what we want here. Mesh. Okay, here we go. Vertex colors. Okay, we have blocks. Okay, yeah, there are some colors there. Oh, I see. Okay. Something that I'm not aware of then. Okay, so yeah, there's data here. It's getting set. Let me do a quick search. Unreal Engine dynamic mesh component vertex colors material. Oh yeah, there's the vertex paint plugin. like from 2014. Okay, so what, I mean, what else would I need to do here? I have a feeling like the vertex colors just aren't getting like set properly or something. I doubt something like the mesh paint works with dynamic mesh, right? I'm not sure. I haven't used any of the... I think you're talking about like one of the built-in tools, like within Unreal Engine. I know you can like... There's a lot of modeling functionality with like geometry script and stuff, so... I feel like it could work, so maybe it does. Okay, so there is mesh modeling tools editor only, and there is a splat shape, and it is using the dynamic mesh. So, potentially Jedem. I don't understand most of the things you're saying, but it looks like a lot of operations are happening. Yeah, the gears are turning, but no one's home, I think is what's happening. There's a little hamster inside my brain. He's not going very fast. Yeah, I mean, this is just, Is there anything else I need to do after I set the color? Like, I wouldn't have thought so. Maybe I should do this at like a different point. We are doing it before we set the material, so never mind. Okay, you know what? Let's pass in a 0.5 into G. We're just gonna hard code that 0.5, and we're gonna see if we get a 0.5. That's what we'll do. And then that's how we can verify if we're actually getting the right data. I'll try to narrow down where it's not working. Live coding, come on. Okay, we're just rebuilding. We're just rebuilding. You go over here. Okay. Okay. So, let's just see. Oh boy, where are we? Okay, so that should be in the green channel if I'm not mistaken. So let's just do... We'll do that. So that should be one. That should be the same. Although we'll need to change that a little bit. We'll need to change that a little. But so that's not going to be right at first. Okay. Okay. And so let's just like we're just gonna fucking. Are they the same? no? Sure. Oh boy. How do I even fucking use that? Color-coded output. Okay. Cross your fingers. Oh boy. Oh, okay. There is information. 111. Is that it? Yeah, I mean, that's, we'll plug that, we'll just get rid of that. Get rid of that one. So it's just 111 everywhere. Okay. Yeah, not the data I want. So yeah, I guess the mesh. Okay, I guess we're just not even getting the vertex color. Maybe I'm not using that node correctly either, but when I did equal to 0.5, it was not equal to 0.5. So I think we can safely say the vertex colors are not getting to the material properly. Is it because I'm using a material instance instead of the material? Chunk biomes on landscape material. Yeah, we're using the dynamic material instances. But, I mean, they all have the same shit on them, right? I think this is Plains Yellow. Was it? Or no, maybe it's Plains Green. I forget which one this one actually is. But, like, I don't know. That shouldn't change anything. Shouldn't change a damn thing. Yeah, maybe I should just like get the vertex gate data, vertex info. At I, and then that way we can see what the vertex is. We can also see if this matches up, right? And it's mutable. Right? Wait, where was the other one that I saw? Was it just get vertex? I think it was just get vertex. There we go. Yeah, yeah, get vertex. Get vertex. Why are you still not resolving to the right one? I guess I need all the true. Let me make sure this is all happening in the right order, because I do change the mesh pointer around a little bit. Where are we? Yeah, we set the new mesh, and then we call render mesh. So yeah, the mesh pointer should be all good. Render mesh, apply material. Although we are returning here, let's not do that. I mean, I know we were still hitting the vertex color. I debugged it. The data on the mesh was there. I did verify that it was there. So, like, that's not the issue. Weird, yeah. Vert info. Dot color. Let's throw a debug pointer there. I have way too many damn windows open. Okay. Okay, what's our freight here? Okay, yeah, we're getting vertex data. It's there. It's there. Those positions look correct. Yeah. I already checked this before. I'll check it again. Vertex colors. They're all 0. Okay, so that didn't even do the update that time. Okay. Let me see what this does here. Get dynamic mesh. Let me look at that again. It is the mesh object, and then there's the mesh. Yeah. Okay, so that's it's not a fucking ref. God damn it. Why is that bad? Why are you annoyed at me? It must be initialized. Oh, wait, why? Isn't there, can't you do like that or something? Just give me, does this return a vertex to, it returns a boolean. Okay, cool, return. Just default constructor, please. What? Or no, it doesn't need to be a ref. I'm dumb. It's a ref in here. Dude, my brain is just going complete mush. It's going complete mush brain mode. Yeah, yeah, that could, well, it's, oh, right, that's not gonna update it. Why did I think that that would update the actual, it's, yeah, it's populating, yeah, I'm fucking, why did I think that that would actually make an edit? That's not how that works at all. That's not how that works at all. That should be setting it. Okay, so back to square one. Let's look at where this is enabled at. What else? What are we doing here? Attributes enable primary colors. Interesting. Yeah, they are just like... Wondering if there's like some sort of update function that I need to call. Destruct per vertex color. The vertex color. Yeah, how are they getting the mesh as well? Where the hell is that? Right here, okay. Out mesh. This is just it's just a mesh pointer. Just a mesh pointer. Yeah, maybe I should do that edit mesh thing that they were doing that they showed me. Let's try that. Let's try this edit mesh function. I think it takes in a lambda of some sort. It takes in the mesh. Is it wait? Which one? U dynamic mesh or F dynamic mesh or F mesh or whatever? F. It takes in the F dynamic. Let me grab that. Takes in the ref, right? Yeah, I guess I don't need I there anymore, do I? I do. I do. Whoops. Stop. Stop. Okay. Read some more here. Vertex color. Interpolate vertex data. Let me see here. I also have the vertex paint plugin. Like I could go dig in that source code and see how they do it, because I know you can do dynamic meshes in that plugin. So. What were the other usages of set? Or rather, enable vertex colors. Just in a copy, enable matching attributes. Enable mesh components. Okay, let's see if rather the edit function worked better for us. I'm sorry, you can go away now. Okay. I mean, we saw the vertex colors updated in there before as well. I don't know, maybe this is better. Maybe this does a proper proper update. Mesh object. Mesh. Colors. Yeah, there's our data. It's there. Yeah, maybe this properly does like a mesh change or whatever. I should probably put the loop inside that though. Oh well. It's still ones. Okay, great. Wonderful. Good news, everyone. Okay, so vertex e-dynamic mesh attribute change flags. What are you for? Oh, I wonder if I should be using the edit functions. Yeah, maybe I should do that. Are there mesh color functions? There are. Okay, yeah, I should probably have been doing this the whole time. I didn't realize there were color ones. Let me see here. What do we got here? Is it all vertex colors? Selection per vertex. Vertex color list. Okay, this is probably pretty close to what we want. What do they do here? Oh, you have to enable attributes and primary colors, it seems. Okay, yeah, let's use this function. Let's use that. Okay, so we'll build the list out there, and we'll do this. Import that. Yeah, get our mesh in there. And then what was the type you wanted? Vertex color list. Okay. Vertex color list. Get rid of you. What do you take in? A list. T array. It's a shared pointer. Why? Why? Why are you a shared pointer? Let's put that there. Okay, and that's it. That's it. Let's try that. So I guess that, yeah, there's attributes and also primary colors, and I guess you needed all of those enabled. Uh-oh. Oh, do I have to make the list first, really? I guess I should just call the reset on it at first. With the vertices number to initialize it. Okay. Wait, what else does this function do? What else do you do? So you did edit mesh, but we were kind of right about that part at least. It doesn't have attributes, enable attributes, if it doesn't have primary color. So I wonder how much more, like, memory these meshes are going to take up now. Okay. Now let's go. Our values are fucking there now. Our values are fucking there. Okay. Okay, and this was round. We were gonna multiply by 100. And then might as well round this one too. Make sure they're both integers. Save. Ba-ba-ba-ba-boo, ba-ba-boo, ba-ba-boo. Okay. Invalid. Right, I have to do point F. Sorry. My bad. My bad. There it is, dude! There it fucking is! Jesus Christ, it only took us fucking goddamn 2 buckety fuck hours. Holy shit, boy. Holy shit. I need fucking therapy after that, man. I was getting gaslit by the goddamn materials. I was getting gaslit by the fucking source code. I enabled the vertex colors, but they weren't fucking enabled. God damn. Ladies and gentlemen, we got him. Okay, get that out of here. Get that out of here. So what made it? I just had to use like the built-in geometry script library functions. Apparently you need to enable attributes and enable primary colors rather than enable vertex colors. So not sure what the deal is there. Oh, it's also setting it on like a triangle. Hello, over on YouTube. Hi, Moxie. Moxie is coming to celebrate as well. Come here. Oh, puppy dog. Hi. Hi, sweetie. What are we doing here? We're rejoicing because... Oh, okay. I am rejoicing because finally figured out how to get vertex data to our procedural terrain, our dynamic mesh chunks. And so this is going to be for our materials that we learn between and stuff like that. Yeah, I don't need to know what ChatGPT thinks about dynamic meshes or whatever. Okay, so let's keep going with this. So value 2 now as well. Save that. God, I need to not be in the habit of saving. Okay. There's dirt. Dirt. Yes, dirt blend amount go there. Good. Now this is. Now we will need to make. Yeah, let's make. Let's go back to doing this one here. We'll get rid of that lerp. Okay. And then we want to blend to dirt there. Let's put that oop. Put that there. We'll go emissive color as well. Save, apply, whatever. Yes. Okay, interesting. Not quite what I was looking for, but that's okay. Okay, And so I was blending this to dirt. Wait a second. Wait a second. I changed this, that's why. That needs to be flipped. Okay. Oh, okay. Of We're getting closer. It looks kind of like shit, but we will start ironing those kinks out. And it's also very shiny. Wait, why is it shiny? I forgot what I did. What were my other settings? Oh no, I got rid of it. Don't I need to like, huh? Oh dear. I think I need to like change like the roughness or something, right? I probably should have made a duplicate of this before I started changing it, shouldn't I have? Okay, that's less shiny. Quite dark though. So I guess let's do like a break material attributes and then a make material attributes. Right. We'll go base color into both emissive and base. Roughness 0 or something like that. Maybe specular fucking 0 or something. Roughness 1, specular 0. I don't know what these values should be. Oh dear, what do we do? It should be this one, right? Oh no, it should be... Yeah, that one actually works too. Okay, that one works. It's no longer sand to grass, so I'll need to change that. Just get rid of that now, actually. Okay, this looks better now. Okay, yeah, I think the specular was being super lame. Super lame. Okay, yeah, you're no longer a thing. Okay, so now we just need stone. Which is this one. So we actually, we're like bypassing. Yeah, we're gonna bypass that one. Okay. Goodbye, world-aligned friend. You are no longer my friend. Friend blend. And so we want... oh god, go back. Give me another one of these. I'll do 3. And let me flip these ones. Yeah, just like that. Beautiful. Beautiful. Looking great, sweetie. Okay. I definitely should have fucking saved this material before I changed it, but what did I say? All gas, no brakes? All grass, no brakes. Like old grass. There we go. There we go! And there's our per vertex materials. Very nice. Very nice. They look like shit. That's okay. We need some cell bombing on the grass and on the dirt. The stone is we just need to get better altogether. It's all kind of bad. We need to blend in stuff as well. I need to let my dogs out. My dog wants to go outside. So I'll be right back. BRB. Okay. It's cool now that we can visualize all of our data now without the need of debug stuff. Okay. So what do we want to do with this? Let's at least blend it a little bit instead of just going like straight from one to the other. How do we want to do that? Okay, so this is going to be grass. Just say grass. This is dirt. Stone. Maybe I should do, well, I don't know how big these are gonna get, so we'll keep it like that. You go away. Okay. And I'll say this is like missing material. Okay. Okay, so yeah, how do I want to blend these from one to the other? How should I do that? I think this is probably where Charlie's video can come into play, which I very, very kindly deleted. Let's find that again. Yeah, let's continue that.
Unstocked.adobe.com, it's easy to find the perfect video with advanced filters that fine-tune your search.
Actual effect. We've got our...
Okay, what did he do here? Let me look back at his little material code here.
Pattern. So we've got
Show me the noodles, Charlie.
Contrast. And just to make this leather data, it's limited to the residual channels to use for some effects and some masks and stuff. So if we look at just the red channel, this is what it looks like. If we look at just the green channel, this is what it looks like. If we look at just the blue channel, then this is what it looks like. So, so far this has been absolutely useless. However, you can do a lot of complex material effects with vertex color. Now, keep in mind, vertex color, as we saw in Blender, is very low resolution, or at least it's limited to the resolution of the vertices of the mesh. But there are ways that we can add detail to break up this gradient. So one of those ways is using a height lerp, which I have a video about up here. It's on my channel somewhere. Just look up height lerp. And the way we set one of them up is we get our transition value, which is going to be the vertex color in this case. We multiply it by 2. We get a texture that we're using as the kind of height texture. I'm going to use a brick wall, and its height data is in the B channel. We're going to get that, subtract 1, we add these together, and then we apply some contrast. And just to make this...
So, I guess how am I going to get my lerp value? And how am I going to make sure that that, like... I guess I need to know, like, what the fucking neighboring verts are? Is that how you would do that? I feel like that's probably not how you would do it. But I guess theoretically this is why I have the B material. I have A and B. So theoretically that should be like that. This is a little weird right here. But that's okay. Yeah, I wonder if I just use that B material. So that would be the green channel. This is secondary material ID. Okay, so do we do the same thing all over again? Yeah, probably, yeah. And we just need to plop this down at each of these. Wait, what? Oh, I'm like, okay. I was creating other ones when I was not intending to. Okay, and so then we would want to, I guess, blend material attributes here, perhaps? And then let's just, like, make that 0.5. I mean, this is going to look really bad, though. This is going to look really bad. Well, no, I want to blend it based on this guy. This guy. This is going to look really bad. Hell yeah. Okay, so there's a lot of secondary none values I'm seeing. Wonderful, wonderful. Let's can I have 2 of these? Yeah, okay, so let's, should we just do 0.5 here? Well, the B, let's not do anything. And it's just black. Okay. Okay. Yeah, so I think my second, oh, I'm just passing 0.5 in there, aren't I? Did I update that? I mean, I did update it here, but I don't know if I rebuilt and reran the code. I don't think so. Do that. Put a breakpoint here. We're gonna stop this. Stop. But I don't know that I necessarily want to blend actually to the material B on the vertex data. I think I would want to just blend to the neighboring, whatever that may be. Show me vertex color list. G is 1. Yeah, do we have zeros anywhere? 009. Which it's all, yeah, it's all like, multiply that by 100. Is that right? No, it's because those would be 0 too. Or would they be 1? Yeah, those might be 1 actually. I hate fucking floating point precision, man. Very annoying. You never have to deal with it in web dev, and it's really nice. Yeah, I'm not seeing. Okay, I think we just weren't populating it. That's why we got the. Oh yeah, that looks good. Gooder, I should say. It looks bad. It looks bad and looks like there's like no rhyme or reason to it. It's just like splattered. It looks like a Splatoon map. Look at that. Look at that. That's so cool. Yeah, that's a high quality material right there. That makes sense. That makes sense. So maybe we can put that back in there. Yeah, because now everything has the proper. Proper data. Okay, so that's the material B is not actually what's I think it should be now. How would I tell each vertex like what it's next to, essentially? So let's let me just see what like just straight up 0.5 looks like. It's just a blur, just a blob. Making some interesting shapes though, like a puzzle. We want 0 though. Yeah, that's what we're looking for. Yeah, how would I transition from one to the other? Because it needs to be like distance based, right? Maybe there's a good example somewhere. I'm wondering if I just need to make the data differently and like do the blending in the data. What is this?
Hello, welcome back to another video. Today we're going to be looking at alert. Let's do that to base color.
Yeah, I think I think this guy is using a vertex color to.
Now this isn't going to be the best result, but hopefully.
Whereas I'm using the vertex color as a color, and I want to learn.
We can see we're getting
based on its like location or something.
Result. We're getting paint on the top of the bricks, not in the grout, and it looks like it's kind of been attributes option. So here we have our material. All the different inputs are opened up, and that gave us. We're using the output from here, the alpha channel output. So that's just going to be the height.
Yeah, that's not quite what I'm talking about. The create a material for two-way texture blending page gives a basic explanation. And I said, okay, cool. Show me that then, please. Can I see this bigger? Okay, just downloaded the fucking image. Sure, sure. Vertex color. Okay, but they have like the blend amount baked into the vertex color. Totally missed an opportunity to draw like a big dick right here. That would have been funny as hell. Blend vertex colors based on distance? Like... Yeah, I feel like this is something that I need to change how I'm generating the data a little bit, I think. Well, congratulations on being able to read. Maybe they'll let you back into GitHub now. Yeah, so it's interesting that it's not that it doesn't let me use the alpha channel in the dynamic mesh. Yeah, I think I need to generate this data differently to do because otherwise, like, how does this vertex know what's on either side of it, right? Oh, I guess it like kind of. Oh, it goes like kind of in between. Okay, wait a second. So maybe there is a way to do it. Not perfectly in the middle, but I thought that was going to line up with the vertices, but I guess not. It's not going to be relevant. It's all blending using like height lerp and stuff like that. I need to watch more of Charlie's video. Maybe I'll pick up some more tricks in here.
A bit more appealing and a little bit more relevant. I'm just going to set this material up so that it lerps between a brick pattern and a kind of destroyed rock stuff.
Yeah, we saw this.
We're going to use a lerp using this transition value between this and our other texture, which is going.
So he multiplied by 2. What does that do? Does that multiply like the coordinate? Oh, Jesus fuck. That is not what I wanted. No, 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 sir. And then he added and did cheap contrast. I don't think that that's going to work for me. Let's try it anyway. What was he multiplying by 2? He was multiplying the red channel by 2 and then just adding it to that, which doesn't make sense. Is this for normals? No, I'm just trying to blend between the neighboring materials now, which is kind of making my brain hurt. Because like, let me go back. That. Right, so like I have these different materials, right? And I want to like smooth blend between them and kind of like Making my brain feel fuzzy.
To be our wall 03 texture. That's going to go into here. This is then going to go into the normal.
Oh.
The color we're going to get rid of. We're going to go between a nice kind of and a little more. All right, and now if we up the contrast a little again, then you can see this is starting to look like, you know, an actual effect. We've got our
Unstocked at Adobe.com.
Yeah, so I guess the difference in how they the difference in how they pack the data is different, right? Because I'm just putting like my IDs into the R channel, whereas they're putting in like the amount of the material into the R channel. And then that way they can use the vertex. That's how, like, all the things I just looked through were doing it. So that way they can use the value to do the alpha or. But if you do that, you don't really have that many. I mean, what's the max amount of blurps you could do? The max amount of textures you could have. I mean, it would be 4, right? You could only have 4. Well, I guess you could do like, I guess it could be up to 8 if you made them like exclusive materials. But all the data is in one channel, right? Yeah, I'm just putting like, I thought what I could do was just like put an ID in here into red, and then just like, yeah, smooth step, min and max value. But see, the thing is like this blend amount is just like, do I want this material or not? Like, hey Odd, how you doing, brother? Hiccup brains? I don't know, my brain kind of hurts. We got our vertex data all built out, and we got it applied in the material, but now I'm like trying to figure out like, how do I blend this shit together, you know? I'm no good at materials. And like the way everyone else uses the vertex colors is different than the way I just used it. And I think that's probably my problem. But the way they're using it makes it seem like they're just restricted to like 4 different materials, and I want a lot more than that. And for like smooth step, what would I pass in here? Because I just have, it's 1 if this vertex has this material, and 0 if it's not. Vertex painting, well, yeah, kind of the same concept. I'm vertex painting, but I'm generating the vertex data for the terrain chunks, so I know like what this is, like my own physical materials solution essentially, right? But that's not how I have my shit set up, so. And like I can't just blend from 1 to 2 to 3, right? Because I suppose there it does it. But like there could theoretically be rock right next to grass, like on top of grass. I guess it's not doing that because of how I have it working. R equals material, G equals material. Yeah, but I'm not using G for anything. It's just R right now. Yeah, I think I need to pack the data differently because it's just not going to work. Man, I hate how materials work. That does make sense that it's not like, it's not going straight to from rock to like there's actually, like if you look at this, there's no vertex with dirt on it here. And I guess it's just doing that because of how I have the material set up, which it probably shouldn't. That should not be the case. The rock should be touching the grass. Yeah, I think I need to change the vertex data generation. Must be a step value you're using in that channel. Yeah. I mean, I just have like I have IDs 1, 2, and 3. 1 is grass, 2 is dirt, 3 is stone. There's either a 1, 2, or 3 here. You know, if it's equal to 1, then this amount is 1. I'm taking all of grass here, and the same, and I just go to do the same for dirt, do the same for stone. So that's why that happens. But that is not a representation of what the data actually is. And the way everyone else was using the vertex color was as a blend between 2 different materials, wherein the data in each channel was how much of color A and B, not what is the ID of the material here. So I think I need to generate the data differently. And I was doing it this way because I thought I could get away with having more in there. It will always blend between from stone to dirt to grass. Yeah, I'm kind of understanding it a little bit more now. And so I kind of need to pack in the blend into the data. But like the way this is traditionally used, I mean, is there a way to not be limited to only a certain number of materials? Yeah, I mean, there should be, right? Okay, so I have well, I have 3 channels because you can't actually do fucking 4 channels here, which is kind of weird. Which is annoying. So I have 3 channels. But I could just pass in, I guess you could pass in texture data, right? Yeah, the enumeration part of it is what I was expecting. That's what I was thinking, right? I was thinking with my fucking programmer brain, because here's my material type enum for like grass, dirt, stone, you know. And I thought, I was like, oh, I'll just pass these numbers into the material, and everyone's gonna be happy. It's gonna work perfectly, and tomorrow I'll ship to Steam, you know. Maybe look into how landscape layer system works. It's blending materials based on O1 values. Yeah, I think it's probably pretty similar to how people were using this, but like I suppose I could put in like I could use like some bitwise math, right? Couldn't you do that? And so you pack in what to If I just change the vertex generation to actually be correct instead of being like this bullshit. Because like when I generated the noise, I like ordered it and stuff. Okay, that looks terrible, but it's blending really poorly. Oh, because I'm multiplying it. Hang on. There we go. That's what it's supposed to be. Yeah, so there's what the vertex data actually is. And yeah, it's not, you can see where like it can't go from one to the other. I guess it kind of does here though, doesn't it? Like, what if you could mask anywhere R50 G20B0 existed in the texture? I have no idea what that means, but that sounds great. Then you could pack any number of materials. I mean, you have like a... I mean, you should just be able to like... There's a way to do it, but it's like, how awkward can it get, right? Because you can always just pass in more parameterized data, right? Like you can just pass in textures as a texture parameter. Should I just do that? Instead of reading red channel as a single mask, yeah. I don't know like the terminology and stuff very well, but like I think I know kind of what you're saying. I think that's what I was expecting to be able to do a lot easier. But if you used some like bitwise math, I suppose if you could put a number into the R channel, and you could do some math to get what two materials they are. And then another channel for blending. But I guess at that point, like, it's kind of already what I have. There's more to figure out, lad. Yeah, I suppose I'm realizing that now. Can you pass in like a texture? Like, is this a named parameter now? Yeah, it is, right? Okay, so yeah, I could pass in, because you can do like a, let me see here. Here's my dynamic material. Yeah, set texture parameter value. So you can just pass in a texture. Right? I mean, this is all making me, I'm following these thought processes in my head, and this is all making me think I just need to generate the data differently. Because I'm just like layering noise on top of each other. And then taking the two highest values. And that's not the two material IDs that I need, actually. It really should be like the strength away from the other one based on distance. And if that's the case, then I don't need to like... I think this gets a little simpler. Because then I just blend between two materials. Well, no, because then I still do this kind of shit. I hate how there's not just like a simple fucking if branch. It's got to be so complicated. I feel like what I should do. I'm kind of formulating something in my head. I'm cooking something up here. So yeah, like I was saying, I just have like multiple noise generations, just like I said, layered on top of each other, and then I just take the highest two, and the difference in strength between the two becomes the alpha, which is not the actual blend that I want. I didn't really think about it very hard. What I want is if this vertex is next to another vertex that is different than itself as a different material, then I want the alpha to be like 0.5 between the two. Right? That's kind of what I want. And I feel like that makes sense for rock and dirt because those are on the same noise. Those are with the same noise params. Oh god. No, don't do that. Test. So I think dirt and stone could always blend pretty nicely. I mean, it doesn't really make sense for grass to blend to stone, but there could just be some other material that I would want to blend grass into. Maybe a stone path, for instance. I'm wondering, how would I get this spatial alpha? Because these are not uniform vertices. This is why people voxelize their data, goddammit. Yeah. With voxelized data, this would not be an issue. I suppose I can use the same method I did. I can use the derivative of the noise to come up with the alpha, right? That's the rate of change of the noise. Let me see what that, what did this one look like again? Let me visualize this. What does our current one look like? I feel like this looks like shit because of how... Like this part looks okay, right? But then there's like this. And what's happening here? This is just from the material, how I have it set up. So maybe I should try to change how this is. That should not be that green. And that should not be that. I think I need a 1- here, actually. Okay, I'll make sure to... You're going to be the tester for that plugin. Make sure to let you know. I guess I could just get the derivative of the noise It would have to be based off of a standard, like a uniform measurement. I don't know, would it necessarily need to be... Yeah, then at that case, because it's just noise in 3D space, so regardless of where the vertices are at, like, I should still be able to determine... Then I can do like a sort of trilinear interpolation or something. Okay, yeah, so I can just sample... This function gets a lot less performant. Actually, I don't know if it's a lot or not, but I would essentially, I guess I have this noise generated, and I would sample the noise at a uniform distance away from each point. And that is effectively my maximum blend distance. Whatever I want that distance to be is what I would need to do. And then I would need to sample the noise in each direction of 3D space, I think. And that would give me an approximation of the analytical derivative. Good enough for our use case here. And that is essentially how I am calculating the slope. That's what this is right here. And I guess I would need to do that for every material noise. Yeah, that's not going to be performant enough. That's not going to be, well, really every noise param that's passed in. So every set of these. Ugh. I mean, it would just be a function. So it would be easy to reuse for each. I would have to loop over it. And then I would get the two highest from that. I guess I am already looping over it to get the two highest, so that would get replaced. It would just be the two highest at 6 different points. Or do I just find the two highest and then, rather than loop through all of, because there could be more than, I only have 2 here, but there could be more in the future. And like maybe just get the 2 highest at this point. And then for all the surrounding points, just only consider those 2. That way it scales a lot better. I don't know what kind of result that would output though. For now, it would output the same thing regardless. So we can start there. That would be a bit more scalable. So I need another function similar to this, but on all 3 axes. So yeah, it's going to be pretty similar to this, except yeah, I will need AI for this. And so it's going to be like a, I'm going to need to pass in, well no, it's going to be per noise, so I would need to do like, going to return a float, and this is going to be like, approximate, yeah, wait, what does this return? What would this return? To return it would return a scalar for the rate of change, if I'm not mistaken. Okay, so it's going to take in noise params into vertex and some spacing parameter. Similar to the function above. And so this normal XYZ do I need the I should probably use like the tangent maybe? To know, then I would only need to go in a certain direction, right? Or do I just get the difference between the two values on either side? I think I just do that, right? The difference between the two values and accumulate that. Maybe get the average. Yeah, do the average of the three directions. Right, so what I'm currently thinking is something like get points at in each XYZ direction. And then get noise value for points in each direction. Lerp between the points, lerp between the point values that are in opposite directions of each other. And then like average the three resulting vertex values, right? Because there's going to be 6 values, pick in the middle of those two. Let me pull up Paint here. So okay, so For a given point, this is the point. That's the point. And the negative and positive values, negative and positive. I mean, would that just give me the fucking noise value that I already have if I did what I'm saying? Or should I instead get the difference between the negative and positive values? Okay, ChatGPT understands what I'm trying to do here, actually, which is kind of interesting. Or Copilot, whatever the fuck Copilot is using. Pretty sure it's some OpenAI model. Would I be doing it? So we're doing this for a single noise per amp. Yeah. And then at the very end, let me go back to what I had. And then at the very end, return the blend distance. Return from 0 to 1 the rate of change over spacing distance. That's what it would return. If it's 0, there is no change. We'll say amount of change. If it's 1, then that means there's a completely different divide this number by this number and the original vertex noise value by the spacing. I have no idea. I'm probably thinking about this completely wrong, right? I may need to cook something up offline. I feel like this number may just return the original noise value, which is not... Maybe I should be getting the difference. My puppy is licking my toes right now. Quite distracting, Moxie. She just scoffed at me. Like, eh. Yeah, I mean, the only way to find out is to try. I just want to plug this into an AI and see what happens. Fuck it, let's just plug this into an AI and see what happens. Alright, Gemini, what do you got for me? That is cursed formatting there. Does it understand? Oh, God damn it. Holy shit. Oh, 1 would be, yeah, a higher rate of change, yeah. The finite difference method, yeah, that's the idea I'm going forward with. Interpreting the user's comments. Okay, let's see what it says about this. Get noise value for points at the plus minus spacing in each XYZ direction. That's what I said. It says this aligns perfectly with the central difference method. We need 6 samples. Beautiful. I'm learning something. Alert between the points that are in opposite directions of each other. This sounds like an average. This doesn't give the derivative. The derivative is about the difference, not the average. Average the 3 resulting values, that's what I said. The resulting values were the differences. Averaging their magnitudes would give a sense of overall change. And then I said, does that just give me the original noise number? Maybe I should be getting the different. And it says, yes, averaging the noise values around a point tends to give something close to the value at that point. The user correctly intuits that the difference is the key for measuring change. Ah! I'm almost as smart as an AI. Holy shit. Divide this number and the original vertex noise value. This seems like an attempt at normalization or relative change, but dividing by the noise value itself is problematic. Okay. Noise often passes through 0, causing division by 0. Yeah. Sense. Returns from 0 to 1 the amount of change over the spacing distance. This confirms the goal is measured as magnitude of change. Normal. Guys, stop. The dogs are barking. Look at that. Look at that little girl back there. It's not even close to time for you to use anything. Mister. Guys, stop. Oh my god. She just ran out. She just like tore out of here like a bat out of hell. Okay, what's your function? Okay. God, it is so nice to have AI to be like, to fill out my like disjointed thoughts into something coherent. Okay, this is interesting. Let's see what this does. This seems relevant. MP4KT, welcome. Thank you for the follow. Thank you. Okay, so I didn't get my struct right. I guess I need the noise. I'm passing in noise params, but maybe what I should be doing is passing in the noise itself. Yeah. I can probably... I guess the problem is that I generate the noise array, and I'm only generating the noise for the vertex locations that I have, which are not uniform. So I guess I need to then write a function to arbitrarily sample it, which I think I'm going to need anyway for some other things. I think that's what I should do next. That's what I should do here. Which is essentially just this. Okay, let's do that. Really, hello. Okay, so we need seed, of course. I. Yeah, we'll just do seed, and then when we pass it in, we'll do the plus I. So we need the positions. So T array, F vector, positions. Okay. There we go. I think that gives me what I want. And then I can just pass in arbitrary positions in here. Like if I only need one, I'll just pass in one. And maybe I can make a little wrapper function for that to make it a little easier. Okay. Okay, so sample noise. Yeah, make that static. I'm going to change the position of you to under this. Sample noise. Where were we? Where were we? Here. So we need noise output sample noise, position array, speed plus I, not 1. So we have noise output there. There we go. I think that's it. I should make sure that that still works. Let's comment all of this out for now. Let's make sure that still works before I continue. Oh yeah, you need to return something. Okay, I need to eat something. I have a protein bar here though. What are we doing here? Okay. Are we going? What's happening here? There we go. I love this comment from Gemini here. In this value. In bold. Okay, yeah, let's just see if that still looks right. This looks like better, weirdly. Okay, but then the stone just kicks in immediately, so I think this is actually... I messed something up somewhere. The only reason it looks better, the data doesn't look better. Only the material. I'm in the git diff. Boisterous, thank you. Welcome in. We're trying to come up with the an approximation of the derivative of my noise functions here, so that I can use them to blend between the materials. These noise functions that I'm using are coming up with the materials that should be rendered. And I'm trying to get them to blend. You can see that they're not doing it very well. And I think I need to change my noise generation process altogether. And we just put it into noise output and we iterate over it and change it. I mean, that should work. We're just changing it in place. And what was I doing before? Why noise in the first place? Because we have procedural terrain. Completely procedural terrain. So it's all noise. It's all just noise. I like the sound of that. Yeah, it's quite noisy. Now, I'm doing literally the same fucking thing. Why is it different? I'm just gonna copy paste this back into here. Run my coding. We're gonna run it again. Yeah, that's what I was expecting. Uh-huh. Okay. Why is that not the same? Why is that not the same as this? Position array. Put that back in there. Put that there. We have noise output, and then we need to do the this thing. Put it into the noise arrays. Add get ref. I guess I can just add. Maybe that's why. Maybe that's why it was wrong. I should have just been adding. Ginny var. Yeah, that's the Ginny. The generator. The Ginny. It Ginny's the dater. Okay, now it's the same. Okay. Yeah, I think it was probably just the way I was adding it to the noise array then. Dare noises. The song's a fucking banger. Okay, this should be the same. Oh no. Okay, gotta rebuild. Love Zelda games? Yeah, me too. I was playing Ocarina of Time on the Switch a little bit ago. That was fun. It was fun. I got to the water temple, and, you know, I haven't had that much motivation to play it anymore. Funny how that works. Okay, that is the same. Okay, wonderful. Wonderful. Now, with this sample, let's make a little wrapper function around this, and actually we should probably call this sample noise positions. Because we're going to do another one for just a single position. And we'll call that one sample noise. There we go. Yeah, my computer very often makes my office quite toasty. And sample noise positions. We're just going to pass in position, feed, at 0, and that's what we'll return in there. Okay, so now we have noise. Noise. Okay. And that needs to go here. Oh, right. This isn't like a class function. But let us make it so. Means we gotta move you. We're gonna move you way the fuck down here. And are we passing noise for? We need the seed. We need the seed. I think I should probably put the seed on the noise params. The like adjusted seed. Seed plus I, and then we can pass in noise param seed in. Okay. Then that way it'll have it in the future. Like that. Okay, make that static. Nice, thank you. Okay. Now we get to find out if this function is correct for finding the derivative approximation. Approximation. I know what the maximum is. Maximum should just be 1. There we go. But now it's gone because I have to click backspace. Always find Control Z. Oh, only 39. That's not too many fuck-ups today. Find that one to be the most insightful. Based on, if your noise has a roughly a range of, the max difference might be 2. Is that what this is? Because the max difference should only be 1. Should mean a 0 to 1 range. I don't think I need it normalized, actually. Because it should already be. Yeah, I think maybe I should use that instead. And smooth step. That's just going to be a lerp at this rate, right? Okay, I think that should be good. Okay, so now what am I doing with this approximate derivative? Wrote a function. Now, how do I use this? Generate vertex data in a height by... No, it should be down here. It should be right down here. The B material is still going to be wrong, I think. Fuck it, let's try it anyway. Spacing, yeah, we're just gonna do yeah, that, which I'm passing in. Let's call that grid spacing. Okay. Yeah, fuck it. Let's fucking see what happens. And yeah, we gotta rebuild here. Okay, I'm gonna run to the bathroom real quick while that builds. Kirby. Dog to go pee off, and they do. Bunch of freeloaders. They need to take themselves outside. When will dogs start paying tax? Coming to a unwarranted political discussion near you. Will dogs pay taxes? Fuck it, yeah, let's just fucking... Okay, yeah, that's lerping, that's not lerping. That's doing the wrong shit there. Oh yeah, because it's just the rate of change, so it's like... Yeah, it's doing the opposite, okay. And even if I did a 1 minus, we'll just leave your door open. Unfortunately, my dogs are 6 and 8 pounds, so I can't do that without having to worry about their safety. And also, dogs like to bark. I'm not about to leave my dogs outside and annoy the hell out of my neighbors. Guys. Okay. Yeah, I need to see like what some of these values actually are. I wonder if this, because like it seems like it's always 0 right now with how I have it set up. I don't think is correct. It's kind of the opposite of what I need it to be. Yeah. Y'all like this like fuzzy green tunnel? The values are precisely opposite. Yeah, let me see. Yeah, let's just put a breakpoint there. I don't think this number is correct. Invert numbers. I will have to do that, but it should be a smooth. Be smoothish rather than 0 or 1. Oh, that is a very small number. Okay, yeah, I'm not generating that correctly at all. We get the difference. Calculate the squared magnitude. And then we square root them all. And then divide them by 2 times spacing. Dividing them by 2, let's not divide it. Let's not do the divided one. Let's just see what the raw number is. Where's the rest of chat? You're it, bud. Lurking. Bro, can live coding please not just, you know, compile at the rate of molasses? That would be great. How do you set up UVs for your mesh? I just calculate them real quick. Okay, we'll wait for this to generate and then we'll get the... Oh, that's different. You can see the one that was generated with the old method. That's something, right? It's just all grass though. Like the material B is all grass. And yeah, I guess that's an issue with how I'm generating it. Yeah, this is going to need some considerable work to figure this out. No. Okay. Well, that was I think a better number. I did want to see what the numbers were. That looks more correct for the derivative. But now like the whole like terrain material A to B is not working correctly. And I think I may just need to change it. Maybe I should just separate every material onto its own noise just to make things simpler. That does slow down the function a little bit because I'd have to generate the noise for each material. Like using this method, right now it's like dirt and stone are kind of like on the same noise channel. What are you asking what language Unreal Engine is in? If that's what you're asking, the answer is C++. Yay. Okay, so we got the breakpoint. Look at some of this data. 0.4, 0.3. Yeah, these numbers look, yeah, these look like what I want. Okay, so we didn't need to normalize it at all or do the grid spacing thing at all. It just looks like my world is moldy. Looks like it's been in a sewer. Turns the analytical derivative. Yeah. Yeah, okay. Okay. Couple things need to change. One, how I'm doing the material, which I'm gonna need to just spend some time learning materials better. Cover with moving grass, it's fine. I do have that. I'm not spawning it right now. But what we're doing this for, it's not just for looks and stuff. What we're trying to do is it's data, the actual data for the terrain. So that's like what it's like. That's the primary material in each point, at each vertex. And so you can see how that doesn't exactly match up with what's there. Could be some stone there, and stone does show up. But, and then we go here, and it's like, you know, it's supposed to be dirt on the side of the mountains and stuff. And this is going to impact gameplay. So, because it's all procedural, I don't have, like, physical materials for everything. And because, like, I looked into physical materials in Unreal Engine, and that's how you, like, change the footstep sound based on what your character's walking on. You know, each object has like a physical material that you can put on it, then you can read that and be like, oh, this is wood, this is stone, this is dirt. But because this is all procedural, I don't necessarily know, and I would want more than one anyway, and there's like a whole can of worms with doing more than one physical material in Unreal Engine from what I've researched. So I'm generating vertex data, and this would most often be voxel data for other procedural generation. But I'm trying to save on memory. I don't want to actually store all of the voxel data for voxels in the middle of the sky, or like things that are, you know, out here in empty space. Like I don't actually need that data. I only need the ones that exist on the surface. And I need to deform. I have deformable terrain as well. So that's another aspect, not just for footsteps, you know, for move speed as well. Like you move faster on, you know, maybe on grass than on dirt or something. And when you deform the terrain, you expect when you hit rocks with a pickaxe, that behaves a little differently than when you hit dirt with a pickaxe, you know? So that kind of stuff. Also for PCG, when I'm spawning the grass and the other things, I want to make sure they're spawning on, you know, I don't want to spawn trees where there's stone. That does make sense. And then also for visuals. It's all been pretty interesting seeing another approach to landscape generation. Yeah, it's like completely backwards. You know, you have to like know everything, and you can't just like model the landscape and paint. You can't just paint onto it where you want the grass and stuff. But yeah, I'll be able to figure this out. I just need some time to actually work through it, I think. This is actually okay. I just need the material, like the method that I'm using here, I think is actually okay, is what I'm trying to say. The outcome of it is not. So I need to change, I think, how I'm assigning the A and B materials to a vertex. Making away how the engine wants you to do things is no easy task. Yeah, tell me about it. Tell me about it. PCG is pretty cool though. That's like one thing that was actually like supportive of my process. But yeah, it's looking like grass is always the B value for some reason. Which ain't right. It ain't right. And then, yeah, this is a side effect of what I'm doing in the materials. So I'll need to find a better way to do that. And I'm not a spaghetti reader, so this is difficult for me. I am no spaghetti master. Oh, we are doing the 1- here. So let me see. Go back to that. Did that get applied? I don't think that changed much. Yeah, it just swapped the the moldy green bits. And here you can see my character. Like another thing I'm doing with this is like I want the world online. Like I want the world running at all times, or at least as much as possible. Like I don't want none of this sphere of influence, like or simulate, you know, just run an equation for how much lumber your colonists are getting when you're away. I want them to actually have to run and get to go chop the trees down. And if there's a wolf in the forest by the trees, I want them to get attacked by that wolf, you know? And so that plus procedural terrain is a giant problem, because that means memory is now my like most coveted resource, which is why I'm not voxelizing my data. And instead just trying to generate it on demand when I need it. And so when I deform the terrain, I'm going to need to rerun that equation for the changed vertices, but only for the changed one. I wonder what's going to happen now, actually. Let's see. But yeah, because, you know, I can actually show this a little bit, but like there are actually terrain chunks out there. There's no mesh there. Oh, come on. Spare me. There's actually terrain chunks out there. They're not rendered or the mesh isn't built. There's no mesh there. I just have vertex and index data that I'm exporting to the nav mesh. And that way I can move my entities within my ECS system around without there actually being any terrain generated. And that way I save on memory, right? So that's how I'm kind of planning to keep the whole world online, as I say. And that means like what you see here is actually my collision trace, because I don't have collision to work with when the entities are out there, right? There's nothing there to collide against. Same with PCG, I don't have collision traces. So I had to take my vertex data and my index data, which represent the triangles, and I had to do some math to do like a collision trace, which is what's happening here, and why you can see I'm getting the data like that. That matches up with the data that's there. So when I walk over there, I'm going to be able to get that data. And this is how I'm going to be able to modify the the move speed of the colonists that are, you know, just moving around in memory. How do you store the vertex IDs? Just by index. There's no ID, it's just an index. My animation is horrible. That's so funny. It didn't assign anything there, so just using the debug texture. That's fucking hilarious. I forgot. Yeah, so I'm not actually regenerating it. I wonder what would happen now, though. Okay, so if I do the regenerate, does this actually reassign it? Oh, but because it didn't change the buffers, right? It didn't change my vertex buffers. That's funny. Yeah, there's the deformed terrain there. So yeah, it's kind of like game dev on hard mode, I suppose. All in the name of replayability and longevity. Gotta sleep? Yeah, of course. Take care of yourself. I might be hopping off here pretty soon. I don't I just feel, what do I feel? I feel like I need to focus real hard on this stuff. And it's just gonna be a lot of me thinking, which is not, it's not good stream content. Also, I ran out of music. So I think that's a good sign. 5 hours. It's a solid stream. It's a solid stream. Who's streaming? Who's streaming? Joseph Bergen. Okay. I've rated him, I think, maybe once before. Or maybe I just followed in, I don't know. Not super familiar with what he's working on, but he is working on Unreal Engine, which is why I think he's on my follow list. So I'm going to send you guys over there. And I'm just going to say thanks for hanging out with me. Thanks for watching me struggle. Struggle was good. We did get some things done here. We got the material actually implemented, so that's good for visualization. I'm happy with that. But yeah, this is going to get more complicated. So that's fun. That's fun. Yeah. Have a good rest of your weekend, everyone. Thanks for stopping by.